Hi everyone, welcome to my channel and welcome to the ultimate Kotlin Crash Course. So whether you are looking to dive into Android app development or build robust backend systems, so this course has you covered. In this comprehensive crash course, we will explore all the fundamentals of the Kotlin to get you started with Kotlin. This Kotlin Crash Course will take you from novice to expert, covering all the essential topics to help you excel in both fields. Just learn whatever is essential. We have covered 48 essential topics in this video which are needed to become expert in Kotlin. Believe me, once you will be finishing this video, you will be fully ready to take into Android or backend development. Also, you can watch this video for quick revision, for interview preparations, everything about starting with Kotlin in a single video, right? So, are you ready to become a Kotlin pro? So let's get started. First of all, continue with introduction and why to learn Kotlin. If you see its documentation, right? So you can see Kotlin is concise, multi-platform and fun, right? And this truly describes this language, believe me, right? So if you see Kotlin in action, so most of the big companies, big names in the IT field, so they are leveraging the Kotlin's power, right? Whether they are using the Kotlin Multiplatform or Kotlin for backend or Kotlin for Android, right? These are the big names, right? You can see. So you can see McDonald's, Kotlin Multiplatform, AWS server side, Philips Kotlin Multiplatform, Forbes Kotlin Multiplatform, Adobe server side, Atlassian server side, right? So whether it is Kotlin Multiplatform or server side or for Android development, now Kotlin is like the first choice of many popular companies, right? So we can share now business logic in Kotlin Multiplatform as well, right? And Compose Multiplatform is for sharing the UI as well. Now you can use the single language for developing app for server, Android, iOS, desktop and web, right? That's pretty cool about this Kotlin, right? So let's get started with this without incorporating any delay. So let's continue with this. So this is the introduction and why to learn. So if you see these many companies and this Kotlin multi-platform feature is just awesome, right? So these reasons are the enough to learn Kotlin, right? The future of the Kotlin is bright, we can say. So now let's move on to the installation and setup, right? So installation and setup. So basically we need to just download the IntelliJ IDEA only, right? We just need to download the IntelliJ IDEA, right? This is the ID, right? So it includes everything bundled, right? You don't need to do any special kind of setup, right? You just need to download this ID, right? You can download it from here, and after downloading you can start with learning Kotlin, right? And even you can try JetBrains toolbox as well. So this is the single app, so it provides you like managing all the IDs, like for updates, installing everything under the one single space, right? JetBrains toolbox. So you can download this. So this is pretty awesome. I have already downloaded this. You see on my system also it exists, right? So that's about this installation thing. So once you have installed the IntelliJ IDEA, so then what you need to do is I have already installed it, so but still I will be like explaining everything like step by step how you can move on to creating the project, right? So first of all, after installation, basically you need to create a new project, right? After you will be creating a new project, suppose this is the like Kotlin project, you can choose, right, Kotlin from here, because this works for Java as well, this ID, right? So you can choose this Kotlin type and you can name it anything, right, whatever you want. Then location and create Git repository. These are pretty simple options. Then you can select the build system, right? Build system is like whatever is used for building the Kotlin programs, right? It can be Maven or Gradle, right? IntelliJ IDEA itself. So we will be using the Gradle, right? Also you can select the Java version as well here, right? You can see currently it is by default on 17 Java version. So open JDK and you can choose other versions as well for 13, or you can download whatever you want, like latest version as well. It provides you every version, right? Whatever you want to use. So this is how it will be, like this bundle JDK it will be using for compiling these programs, right? So Kotlin is basically JVM based language, right? It also needs the JVM for running, right? So this is it, and we can select the Gradle DSL as well, whether it is Groovy or Kotlin. Nowadays Kotlin is also like becoming the popular choice inside the Gradle scripting, so we can choose the Kotlin itself, right? After this, creating the new project, so then you will be like getting some main file which will having just the main function, right? You can create, suppose inside this Kotlin source set you can just create a simple file, right? If that does not exist, you can create simple file, and inside that you need to define this method, main method, right? That is the entry point of each like Kotlin program, right? So if you see, it provides already you actions for running this main function, right? The files code, right? So if you see now, you can run, debug, or whatever you want to do, right? But if you just rename it to something else, you can see that action will be gone, right? So that's why method name should be fun, right? And basically it also accepts if we are running from the command line, we can pass any number of arguments from there, and we can print these arguments, or we can use whenever we need, right? Suppose you can see the name of this file. Suppose this is the name, ch01 variables and reserved keywords. So ch is like for chapter 1, right? So .kt. So this, but for while running it, for configuration, like it, how it creates the configuration, like it appends the kt after the name, with instead of .kt it appends it like first k in uppercase then t small, right? This is the configuration it creates, right? We can see this configuration basically. These are few options, and we can pass the arguments here as well, right? If you see, so if we can try to pass arguments from here, it will also print them if we like use this args, right? But ideally they are like used for like while we want to run these files from the like command line, right? Let's move on to the next chapter. So this is about variables and reserved keywords, right? So how we create variables? So basically variables are like containers for holding data related to programs. Suppose this is our program, or right, some class or anything is there. So how we will be holding the data? So using the variables, right? So there are two types of variable we can create in Kotlin. So one is the, suppose, so this is the mutable variable, right? With the var keyword we can define the mutable variable, right? So this is the mutable variable. Mutable means it can be mutated, right? It can be changed later on, right? And we can use the val keyword for like creating the immutable variables, right? And if you observed one more thing, we don't need this semicolon at the end of the line, right? In the Kotlin, that is option we don't need, right? Now let's try. Suppose if we want to reassign the age 26, it works pretty fine, right? But if we try to reassign this, if you see, it will not allow. Change to where? Val cannot be reassigned. It will show this warning, right? So because that is immutable, right? We cannot change its value once initialized, right? And similar to the Java system.out.println, we use the println here, right? For printing anything on the console, right? So here we are printing the age, and then let's print name, and let's try to run our first program. If you see, but you can see 26 Kotlin, there is no new line, right? Why? Because we use print here, not the println. So print just prints the text, and but println prints the text and moves the cursor to the next line, right? If you see now, 26 Kotlin, right? So this is about the variables. Move on to the next chapter, lateinit. So what are lateinit variables, right? So basically these are non-nullable variables that will be initialized later, right? So non-nullable variables that will be initialized later. So, and one more thing, so they cannot be used with primitive types, right? Suppose the lateinit keyword. So basically I will give you one example. Suppose I have one class lateinit example, okay, and here we have suppose lateinit var name, suppose that is of kind string, right? This type is string, and suppose one function is there. So as of now you can just assume this keyword is used to create the functions, right, or methods. Initialize name, right? Suppose this method will be initializing this name, right? If you see, so if you see now here this type is lateinit, but if we remove lateinit, so if you see either it should be lateinit type variable or be abstract, right? Or otherwise we need to define some value, right? But if we don't like assign any value, it will, because this is the variable type, it will ask for like whether it should be lateinit if it is variable, right? If we are not assigning any value, or either we can assign some value, right? Suppose at some time what happens is we don't know the whatever can be the value of some variable, right? So then we can add the lateinit. So it means it will be initialized later, right? Depending upon some other work, it will be initialized later. So that's where we use the lateinit keyword, right? So let's create the subject example dot initialize name dot suppose let's add one more method, print name. This fun keyword we will be discussing it in the some other chapter where we will be discussing the functions. As of now you can assume this is the method, right? So but if suppose variable is lateinit, one more thing we need to do is we need to check is initialized, otherwise it will throw exception. In case, suppose what happens is, right, I will give you an example, just wait. So if you see, I will show you now. What happens is, if it's initialized, then it will print name. Otherwise, in this case, suppose if it is not initialized, we are printing the name, right? We are using that variable. It is not initialized, but still we are using. Let's see what happens. So because if we use that without initializing, right? So let's call that function print name. I will show you what happens. If you see, it throws exception. Lateinit property name has not been initialized, right? So this is one of the risks while we are using the lateinit variables, right? We need to make sure, either we need to make sure it is initialized, right? Or we need to check it if it is initialized or not manually, right? So if we do this, initialize it and then run, you can see there is no error is gone, right? So when sometimes we don't know like what can be the value of some variable, we can use the lateinit keyword. But one more thing you need to remember is, either we should be sure whether it should be initialized by the time we are using it, but this is the safe bet, right? I think we can use it using this way. If it is initialized, only then use it, right? And it cannot be used with primitive types, right? Byte, short, int, long, float, double, etc. These types, it cannot be used. It can be only used with custom classes or maybe non-primitive types like strings or custom other classes, right? And it cannot be used with primitive types, right? Like with these int, byte, short, long, float, double, etc. right? So it can be used with like string, some classes which are known primitives, right? Let's move on to the next chapter, that is data types, right? So for each variable, if you see, suppose we are defining some variable, right? We need to define the data type as well, right? So Kotlin has a multiple data types. I will be covering each of them. So basically we have number and floating point numbers, characters and booleans for types, right? Basically main types are these four. Then inside the numbers we have like integer, long, byte, short, right? And inside the floating point numbers we can have float, double, right? And then characters and booleans. Then strings, arrays, those are also the like non-primitive types, right? So using this colon, suppose this is the val keyword used to create the variable, this is the variable name, and this colon is used to define the type of this variable, right? And this is its maximum value. Similarly, we can have short value, like that is depending upon the range, how long number we need, right? Depending upon that we can define these values. Its maximum value is 127, its short maximum value is 32767, right? If we need numbers larger, even larger than this, we can define int, right? Here, right, we can define int. And if you, I don't know if you know or not, so int has very long value, 48367, I think, this one. So basically this is depending upon the like integer is of 32 bits, right? And short is of 16 bits. So basically depending upon the bits we calculate this size. So for it is 16 bits, so it will be like 2 raised to power 15 then minus 1. Similarly this is 32 bit, 2 raised to power 31 minus 1, right? This is the maximum value for this. Similarly we have other types as well, right? So we can define long value as well. For that we use the long type, right? And it can have even larger values than this, right? Right, a very larger value. So basically it will be like maximum value will be like 2 raised to power 63 minus 1, because it is of 64 bit, right? It is of 32 bits, it is of 64 bits, 16 bits, 8 bits, right? If you don't know about bits, so basically these are the terms in which data is stored in the computer, right? Similarly we can have float value as well, right? So for that we use the float type, right? Suppose we want to use some like decimal inside the numbers, right? So then we need to use this float type, right? And we need to use this f for defining it, like the float type. Without this it will not be, it will show initializer type mismatch, because here for type it needs f. Okay, similarly we have double value as well, right? Which is for even larger values. For suppose we have like a lot of number of decimals, right? We need a lot of decimals, right? Then we can use double. So basically it has some limits. So in the float basically we have 6 to 7 decimal points only, right? But if you go in double, like it can have like 15 to 16 decimal, right? And this is 32 bits and this is 64 bits, right? Then let's go to the char, right? So basically char, so we use the char keyword for that, right? And for char we need single quotes, right? Then we have boolean. For boolean we use BOOLEA and boolean, right? So this is similar to the Java. Mostly in Java we use the small b for boolean, right? It again have like either false or true. It can have two types of values, right? And just for testing we can print any of these, right? We can print boolean and maybe some float value as well. Let's try to run. If you see, for short, for float, for boolean, right? So this is about the data types. We can use the colon and then data type for the variable, right? So if you see, this is general syntax. Val, variable name, colon, its type, it's some value, right? Let's move on to the next chapter, constants, right? So basically what are the constants? So values which are known at compile time, right? Compile time, you mean like whenever we are compiling the program, whenever I will be running it, before running this, it compiles the program and then it runs it, right? So at the compile time, which values should be known, those are called the constants, right? So how we can declare the constants? Const val, right? Const val. Val, these are the kind of val variables, right? Not the var, if you see. But const keyword makes them compile time constants, right? But val are also the constants, you can see, because they are immutable, but like they are not known at compile time, like, right? Their values can be like, we can use the val types with those values which will be evaluated at runtime as well, right? Which might not be known at compile time, right? That is the difference between val and const val. Suppose const val for pi, right? We can define the pi constant because we know pi is a constant, right? And we can just try to print it. We can use it. Two important things about the constants, right? We can print it using the println statement. So there are two important points about these constants, right? So one is like we cannot declare them inside the local. Const val is, if you see, it will not allow you. Modifier const is not applicable to local variables. Either we need to define them at top level or maybe inside the static classes, or maybe you're using the object keyword in the Kotlin, you can define them inside those, right? So this is about the constant. And one more thing which I forgot to mention, if you go here, so even if I remove this type, right, you see, if I remove this type, still it's working. It's not asking it for like specify the type. It's not showing any error, right? Compiler is not showing any error. So this is the like type inference, right? So Kotlin compiler automatically infer the type of this variable from its values. Suppose this value is false. So Kotlin compiler now knows this variable has a type of boolean. So it will not force us to like define the type, right? This is called type inference. Let's move on to the next chapter. Strings. So string is basically a collection of characters, you can say, right? So strings are immutable. So what is the meaning of immutable, right? Whenever we perform any kind of operation on string, it creates a new variable from that, right? It does not modify the existing ones. Whenever we were performing any kind of operation, anyhow we will be modifying some strings, that then it will be creating the new variables for that, right? That's why we call these strings immutable, right? And alternatives are like string builders and StringBuffer. They are mutable. We can modify them, right? For whenever we will be modifying them, it will not create the new variables for them. But strings are immutable, right? So how we can create these strings? So Kotlin automatically infers the type, right? So I have defined this string, and if I will define its type, then also it is fine. If I don't define, then also it is fine. But let's define, we are discussing about the strings, make it more readable, right? So this is the simple string, right? Similarly we can create multi-line string as well. So how we can create that? Triple quoted syntax, right? If you see, it automatically add this trim indent method for removing the spacing, right? So here we can define string in the multiple lines. Okay, this is multi-line string, and then we can define escaped string as well. So escaped string means this is an how we can escape some character, right? So if inside this string I want to use again double quotes, how I can use? Whenever I need to use special character, I need to use backslash, and here again backslash, and here whatever you want to use, we can define that escaped, right? String. And then we can have string templates. So let's keep printing them as well. Multi-line, name, escaped. Then we have string templates, right? So what are string templates basically? Suppose we have this string val country. So while printing it, suppose I want to like show my name is $name, whatever we have defined above, right? This one. So if you see inside this string, we have used the dollar syntax, then the variable name. So this is the variable. Whenever we can use the variable or expressions inside the string, that is called string template, right? And also if we have some kind of variables, right, name dot length, this is expression. For using expression we can use the dollar then curly braces, suppose. But if we have simple variable, then we can remove the curly braces, right? This is called string templates, right? Right. So this way, right? So then let's move on to some useful methods, right? Suppose this is name. So what are the useful methods? So first of all, let's define the calculate the length. Length is very useful method if we need to like get the length of the string. Useful methods, right? Length. So length is like getting the length of the string, right? Let's try to run these before this, right? If you see, it's printing everything. So for coding ambitions in single line, this is multi-line string and it's printing it in multi-lines, right? And this is escape string. If you see, now inside this string we have escaped these double quotes, right? And here we use the string templates, use that variable, right? And then the string templates using expressions, right? And this is the length. And then we can have accessors, right? So it will print basically what character is at 0, index 0, right? If you know, string or arrays are 0 based indexing, right? So index starts from the 0 till the length minus 1, right? suppose length is 5 for string, right? If we want to access the 5th character, how we will access that? Using the index 4, length minus 1, right? So it will print C. And then we can have the like substring, right? So substring is, suppose we want some part of that string, right, from and to index. So basically this, so this will like print it from 0 till 6. Why 6? Because this is excluded. We need to remember this thing. This is excluded. It will from this, it will start from this, include this, but this one will be excluded. Before this it will include all the characters, right? 0 to 6. If I see, you can see coding, right? 0 to 6 is printed, right? Then we can have name dot contains method for checking if this string contains some other string, right? So it will show us, you can see false. Why it is false? Because that is the capital C, coding with capital C, right? If you see, coding with capital C, right? But here it is small c. And if you see, we can specify ignore case as well. By default it does not ignore case, but if we specify ignore case, then it will print true, right? Ignore case means it will not consider like uppercase or like lowercase, different ones. So if whether this character is in uppercase or in lowercase, it will consider that same, right? Next method can be replace, right? So how replace works? If we want to replace some substring, right? So basically, if we want to replace this coding with Kotlin, right? So it will replace this word with this word, right? If I try to run it, you can see the coding ambitions now become Kotlin ambitions, right? This is for replacing, right? Then we can have some other methods like uppercase, lowercase, uppercase. It will like convert all characters to the uppercase, right? Then we can have lowercase, right? If you see, it converted everything to the uppercase. It converted everything to the lowercase. And if you see now, because each function we are using on this string, it is not modifying the original one, right? If you see, I have now replaced this, but here again I printed it, but it printed coding ambitions, not this Kotlin ambitions. It means whatever I said in the beginning. So Kotlin strings are immutable. Each operation we perform on strings, it creates a new instance from that, right? Some other useful methods are like is empty, right? Or maybe we can use the blank as well. Is blank, same one, right? Similarly, we can use is null or blank. It will check for both, like if it is either null or blank. If it is any one of them, like if it is null, it will return true. If it is blank, then also it will return true. Similarly, we can have empty, and it is showing like colon not null type may be reduced. Why it is showing? Because name is defined as not nullable, right? I will come to that point as well. What are the nullables in Kotlin, right? For the sake of this chapter, we will be just learning about these Kotlin strings, right? Now let's come to the StringBuilder and buffer. Those are the mutable versions of the strings, right? So how we can create them? Using this constructor. For StringBuilder, we can create it like this. So the StringBuilder is not thread safe, right? So if we want to use the manipulation on strings in single threaded environment, then we can use this. because it does not provide synchronization, but it is fast as compared to StringBuffer. And StringBuffer is thread safe. You mean you can access that from multiple threads as well, right? So SB dot, what we can do is we can append any values to this, right? Any number of arguments, right? If you see, and even we can define some initial value inside this as well, right? Hello world, or we can define multiple values as well. Hi Kotlin, right? It will append all these words with this, right? And we can use insert as well. Suppose if we want to insert at some particular index, suppose at 0 we want to insert something, suppose hi hello world, hi Kotlin, and if we print it, what it will print, you can see hi hello world. So first it created hello world hi Kotlin, right? So this string it created first in first attempt, right? Then we inserted at 0 index, we inserted this string of length 3, right? It added that, if you see, right? This is for inserting. And similarly we can have StringBuffer, right? Methods are almost similar for both of them, right? If you see, it will be printing the same thing, right? So this is about the strings. So let's move on to the next chapter, arrays. So what are arrays? Suppose if we need single values, so we can just use the simple variables, right? But if we need like multiple values of same type, right? Suppose if we need multiple values of integer types, how we can use them, right? So there are a couple of ways. Lists are also there which we can use, but arrays are also like the collection of similar type of elements, right? So we can use arrays here, right? So that's the difference. Single values if we need, so then we can define simple variables, but if we need collection of similar type of elements, right? Suppose if we need multiple integers, like, so we can create the array of them, right? And suppose this applies on other classes as well. Suppose we have some employee or user, right? User, but if we need single value, we can create user1 variable, right? But if we need multiple values, we can create arrays there, right? Or maybe lists as well. But here we'll be learning about arrays. So there are two ways to create arrays, right? So first one is using the array of, this is the function which we can use, right? Kotlin Java, right? So this way array of, and then we can define all the elements, right? And it will automatically infer the type from these values, right? If you see, it will show type of array of string, array of string, right? And how we can access their values, println names. So because arrays are again 0 based indexing, right? So this is at index 0, this is at index 1, its length is 2, right? But if we want to access second element, how we can access? Length minus 1. Sorry, last element, how we can access? Using the length minus 1. Suppose we want to access 0th element, then first how we can do that? You can see Kotlin Java, right? This is the one way, right? Okay, the second way can be array constructor, right? Here we can specify its size and then these curly brackets, and then so this is the array of size 5 and each element is initialized to 0, right? If you try to print it, at 0 index it will print 0, right? And how we can modify it? So basically we can use the same way, like how we are accessing it. Similarly we can update it as well. On 0, if we want to change it, we can assign 1, right? If you see now, if we print it again, it will print 1, right? So this is for updating the values, right? And if we want to print the whole array, how we can do that? Dot content to string, right? It will print the whole array, if you see, right? Then we have type specific constructor as well, right? So this is the generic constructor, common, it can accept any type. Then we have type specific constructors as well, right? So if I want to create int array, so what we can do is int array constructor we can use, right? With size 5, and each element will be initialized to 1, right? If you see int array 1, each element is initialized to 1. Similarly we can have, I would like to show you float array, right? It will like define each element as float, right? Similarly we can have double array as well, right? And long array as well. So these are type specific array, right? We can create float array, okay, 1.0 float array 1, okay. If you see, similarly we can have like, these are the type specific constructors, right? And similarly we can have this function based as well, like using the array of function. This is for common, any type. But if we suppose want to create int type, right? Int array, right? We can use int array of directly there, right? 1, 2, 3, right? And if I print this, you can see it is again the same 1, 2, 3, right? You can see it 1, 2, 3 here, right? Similarly we can have this for float array of, right, double array of, long array of, type specific, right? And suppose when we should use these ones. So if we know like we have a fixed number of values, we can directly use this like int array of. But when we don't like want to initialize all the values, when we want to initialize fewer values are there and we want to initialize all values, we can use these function based. But if we want to like, we don't know, like we need to update those arrays later and we want to define like 20 values, right? Or multiple large number of values, then we can use this constructor base as well, right? Then some useful methods which you might need, right, while working with Kotlin arrays, right? For most of the topics we will be covering these useful methods, right? So suppose you want to get the first element, you can directly use the first, or maybe directly you can use the indexing operator as well, but these are the like some methods. Last, right? And if you want to get the size of the array, right? And then suppose we have some element, we want to get the index of that element, right? Suppose, right? And then we can have copy function as well, right? Suppose names dot copy of, right? It will create a copy of this same array, right? If you see copy 1 dot content to string, it will print same, right? by mistake we updated the size of this array. So that's why, because size we updated to 0 and it shows index 0 out of bounds, right? So let's try to run it. If you see, so this first is printing the first element, then the last element, then the size is 2, then the index of Java. So because it is 0 based indexing, Kotlin is at 0 index. So for index Java, what will be the index? 1, right? Then we create the copy of this array, right? So this will create copy. If we print it, it will print the same values, right? It is the copy of that array, right? Then we can have contains as well, similar to the strings, right? Right, it will print true. You can see true, right? Then we can, like, if we want to get sum of some kind of elements, right? Suppose it dot, suppose so on some integer arrays we can apply this. Suppose we want to get this sum, array dot sum, right? It will sum all of them, right? If you see 6 for the int array, whatever elements were there in the int array, 1 2 3, sum of them will be 6, right? So these are some of the useful methods for the arrays which you might need to use, right? So let's move on to the next chapter, that is two-dimensional arrays, right? So basically arrays are array of some elements, some kind of types, right? But two-dimensional arrays are array of arrays. That is the main difference between them, right? We call them matrix as well, right? Suppose we want to create an array of size 3, and then again we have int arrays of size 3, right? So basically it will like create an array with elements 3. So this array will have elements, total elements as 3, right? And each element is again an array of size 3, right? If I show you by printing this matrix dot, if we want to print two-dimensional arrays, we can use content deep to string. If you see, right, so this whole is an array, right? And inside this we have 3 elements. This is the first element, which is again an array of 3 elements. This is second element of that array. This is the third element of that array. Each of the element is array, right? So if you see, if I show you, so this is basically the first row, this is the second row. So if we print them like this vertical, like in the horizontal or vertical order, so in the horizontal, right, the horizontal length is called row, right? Horizontal, if we read them horizontally, like 0 0 0, so it will be becoming like this, right? Right, so this is the row, right? This is called the row, right? And if we traverse them vertically, or we see them vertically, this is the column, right? And this is the row. So if you see, so what if we want to get the like last row, right? So what is the last row? This is again the having the 0 based indexing, right? So how many elements are there? 0, this is at 0 index, this is at 1, this is at 2 in the first row, right? How we access its elements, right? So let me show you. Println, suppose I want to access, so this is the 0th row, this is the 1th row, this is second row, right? Similarly if we traverse it from here, and you will see this is the 0th row, this is 1st, this is 2nd, right? 1th, or you can say 1st, right? So if I want to get this element, so right, so this is on the 2nd row, right? This is the 0, this is the 1st row, this is 2nd row. And if we talk about the indexes, so this is on the 0. If you let's add it here for better understanding. 0, 1, 2, right? Similarly here also we add like 0, 1, 2, right? So these are their indexes, right? Okay. So if we want to access this element, so if you see, what is the row number? Sorry, what is the column number? 0, 1, right? 1 is the column number. And what is the row number? If you see, 1. So first we need to use the row, then we need to use the column number, right? Let's add 1, 1. Okay. Or maybe let's use the another way of creating the array. There is one more way which exists. Matrix. So let's make it 2. And suppose int array of, suppose we want to define some with some predefined values, we can use way of creating the array using functions, right? If you remember, I told you just a moment ago, right? So if you see, and here we don't need size, right? Int array of 1, 2, 3, right? So this is, if you see now, this is the first only one element, right? So this int array of, inside this we have specified only one element. This is different thing. So this is, if this is the constructor base, it will initialize each element with whatever is there, right? Each element of this array, size this 3, and each element of this array will be initialized with this, right? But here we are not specifying any size. Whatever we will be defining here, those will be the values, right? So this is like first, this is second, this is third, right? Suppose, right? And here it will be using the simple brackets, right? My bad, we don't need to use so let's create another array matrix that is like array of using the function, using the functional method, right? Because we need some fixed values, right? Then second array can be 4, 5, 6, right? Make it matrix 2. So if you see, if for these elements, right, even let's add, right? So it is 1, 2, 3, 6, 9, 8, 7, 4, 5. If we want this element, so what it will be printing is, if you see 5, because it is at first column and first row, right? If we want this element, so row number is 2 and column number is 1, right? So 2 and 1, so it will print 8, right? So similarly we can use rows and columns, right, for these two-dimensional arrays, how we can print them, right? And if we want to get the size of row, so we can directly call it on matrix.size. So why? Because size of this array, right? So how many elements it have? They becomes rows, right? So they becomes rows. So it have 3 arrays. If you see here, it have 3 arrays. So there are 3 rows, it means, right? This is for row size. And for column size, how we can do that? So basically from the matrix we can get any of row, right? For any of the row we can get it, and then we can get the length of this row. That will be the column number of columns, right? This is the col size, right? Okay, if you see 3 by 3, because this is of 3 by 3, and if I remove just this one, it will print. We need to remove this one as well. Yeah, you can see 2 by 3, because now rows are 2. You can see first row, second row, and columns are 3, right? So this is all about two-dimensional arrays. Let's move on to the next chapter. That is about the conditionals. So what are conditionals basically, or we can say control flow as well. When we need to control the flow of program depending upon some conditions, right? Suppose we have age 15 and suppose we want to check it is adult or not. So what we'll do is, so there are some conditions here. Suppose if age is greater than or equal to 18, we can say it is adult, else we can say he is not adult, right? So we can use if else here. If you see age is greater than 18, so return true, else return false. So basically this one is like original structure is this one, right? If this one, right? And this way, suppose if you want to check like if his user is adult or not, right? His age is 15, right? If age is greater than equal to 18, inside the if block we have some condition, whatever we are checking. If this condition is true, it will come inside this if block, else it will go to the else part, right? And if you see in Kotlin, we can, whatever is returned from here, we can directly use and assign it to the variable. So this is like as expression, right? And if we just add some logic here and print something here, this one, it will say like adult, and else we print not adult, right? So this is if else as statement, right? So we can use if else as statement as well, right? Then we are not returning any value from if or else. This is used as statement. But if we want to return something from it, we can use it as expression as well. And whatever is inside the block, whatever is in the last statement will be returned, right? From both blocks, right? And if we have just single statements or single values inside these blocks, right, we can omit these brackets, you can see, and we can just write that in this single line as well, right? And so this is about for two conditions. If we want to, like, we have two conditions, if something is true then do this, else this, right? But if we want multiple conditions, right, then we can have if else if, right? So let's use some other number, and suppose if number is greater than 0, we can say it's positive, right? Else negative. And here we can introduce if else if as well, right? And this will go inside the else, and we introduced if else if as well, right? So it will become like this, if else if else, three conditions, right? So we can have as many as we want else if in between, right? We can, but in the first it will be if, on the last it will be else, inside we can have multiple else ifs as well, right? If here number is 0, right? So then let's print 0, right? This is for multiple conditions, right? If you see age is 15, so not adult, right? And number is 10, it is positive, right? Then we can have when statement as well, right? In Kotlin, suppose we have multiple, like if else, if multiple conditions, we can use when clause as well, right? Suppose we have day 3, and suppose it can be like anything between day 1 to 7. If day is 1, so println Monday, right? Tuesday for day 2, right? Then Wednesday, Thursday, Friday, Saturday, and Sunday, right? So if you see, because if we will be writing it using the if else if, it will become many else if will be there, right? But now we can write it with using the when statement, right? This is similar to the switch in other languages, right? And similarly we can use when as well as expression, right? Similarly we can use when statement as an expression as well, right? Suppose this is the day 1, some other variable, and we want to return something from here. So what we can do is, we don't need to do anything, just return. So whatever is there, it will be returned, right? If there is single line, that will be returned, right? If there are multiple lines, then we need to use the curly braces, and whatever is inside the last line, that will be returned, right? And if you see, if I use it here and if I have something here, so then it will return this. And if we have suppose something here as, so it will return this one, whatever is in the last line, right? For example, we can print it as well and then return, right? It's asking for else branch. Why it's asking for? So basically it must be exhaustive. It should know about, like, if value is not like among these, right? 1 2 3 4 5 6 7, so it is integer, right? It can be anything, right? So we need to define some default value in the else block, right? None, right? And we can print this variable, right? You can see it printed 3 because day 1 was 3. Oops, we printed day 1, so we need to print this string day, right? So if you see, it printed Wednesday because day 1 was 3. It printed this value inside this variable, right? So you can see, if, else if, and when, there are two ways to control the flow of program, right? And they can be used as statements as well and as expression as well, right? So they can be like, their values can be assigned to some variables as well, or if we don't want to do that, we can just use them as statements. Similarly, when statement, right? This is when statement and this is when statement as an expression, right? Whatever is returned from this, it will be assigned to this variable, right? So let's move on to our next chapter, that is operators. So operators are used to perform some kind of operations, right, on two or more variables, right? So suppose we have two variables, right? Then we have will be, that is 5. Suppose we want to perform addition, right? Sum, so it will be like a plus b. So plus is an operator here, right? You can see, so there are many operators. There are arithmetic operators like plus, minus, multiplication, division, modulus, comparison operators like greater than, less than, less than, greater than, less than, equal to, greater than, equal to, then logical operators and or not, right? So basically these are arithmetic operations. They perform some arithmetics, right? Plus, minus, division, right? If you see, we can use difference as well, multiplications as well, division as well, right? Modulo as well. So modulo just using for returning the remainder. So modulo is just used for returning the remainder, right, of the division, right? Whatever is remainder, it returns that, right? Similarly, we can have these comparison operators as well, right? Let's print them as well. If you see, multiplication mod, right? If you see, sum is 15 and then it printed division. Division will be like returning true, and then we have difference. It is like 5, 10 minus 5. Then we have multiplication, 10 into 5, 15. Then we have modulo. Because it is completely divisible, there will be no modulo, right? But if inside the modulo we do like 7 modulo 2, right, it will print 1 because it will like multiply first by 3, then it will be like 2 into 3, 6, then what will be the remainder is 1, right? 7 minus 6, 1. Then we can have these increment and decrement operators as well, right? Suppose a plus plus, it will increment that, println, and if we use, so let's use some number here. Basically num is 5, right? So it is like postfix operator, right? It will first use that variable. Oops, it is there. Yeah, we need, because if we want to change some variable, any kind of variable, we need to define its type as var, right? So suppose we want to modify this, increment it by 1, so we can use this increment operator. But this is one difference between these two increment operators. So this will first use the variable, then increment it. It will first increment the variable, then use it, right? If you see, this printed 4, right, then incremented it, so now it becomes 5, and here it incremented first, so from to 5 it incremented it, it becomes 6, then print it, right? This is postfix increment, this is prefix increment. Similarly, we have decrement as well, right? If you see, it will again decrement it 5, right? Similarly, we can have like comparison operators as well, right? So let's check if A is greater than B or not, right? If you see, true, because A is 10, B is 5. Similarly, we can have less than as well, right? If you see, false, because 10 less than 5, that is false, right? Similarly, we can have like with equal to as well. It will check like if it is less than or equal to. If it is like, it means like it will check if it is less than, right? Exactly less than. It will check for like if it is less than or equal to. Similarly, we can have greater than equal as well, right? Now let's move on to the assignment operators. Similarly, suppose we have var d and that is 20, and we want to, suppose we want to do this kind of thing, right? D is equal to d plus 5, right? So short form of this is like plus equal 5. So it will like first add 5 to the d, then assign the same value to this d variable, right? These are called assignment operators, right? Assignment operators, right? Similarly, we have this for all of them, like plus, minus, addition, subtraction, right? Then we have logical operators, right? Suppose println, and here we want to check some conditions basically, right? So suppose let's apply them on var1, that is false, and var2 that is true, right? So logical operators are assigned to some, they work on some values, right? If you see var1 and var2, so if both of them are true, it will return true, otherwise it will return false. If you see false, right? Similarly, we have OR operator as well. If both conditions are true, if both or any of these, in all cases it will return true. But if both are false, only then it will return false, right? If you see true, right? Then we have not as well, right? So it will check. If you see, it will check not. So it will do it opposite. It will check its opposite, right? Suppose if it is false, it will make it true. It will check. If this is true, it will return only true. Suppose, right? Suppose if it is false, then this expression will return true. It is like the kind of opposing the value, right? If it is false, it will return true, and if it is true, it will return false, right? So basically you can see var2 false, but it was true, so it opposes it made the value opposite, right? Negated the value, right? So you can see these are the conditional operators as well. You can logical operators or conditional operators as well. We can say if we want to check some kind of conditions, we can do that, and similar thing we can do on variables as well, right? Suppose we want to check a less than 5 and b less than 6, so it will check for these values, right? These conditions. If both of these conditions are true, then it will return true, otherwise it will return false. You can see false, because a was 10 here, so a was not less than 5, and b was 5. This was true, but this was false here, right? So you can see this is all about the operators. The next chapter, loops, right? So what are the loops? Loops are used to like iterating the collections, arrays or ranges, right? Or some other use cases can be like if we have some logic and we want to repeat that logic multiple times, right? Suppose 10 times. So then also we can use loops. And if we have some conditions, right? Suppose if we want to repeat some code until those conditions are true, then also we can use the loops, right? And when that condition becomes false, then loop will be break, right? So let me give you one example. Suppose we have array of fruits. Okay. And we want to like, we need each one of the values from this, right? Here we can give it any name like the item in, then we need to use the in clause, then the list or collection or range, right? Anything, right? Like that is the iterable. Suppose if it can be array, it can be list, it can be ranges as well, right? In Kotlin you will understand about these as well in the coming chapters, right? So if I go here and print it item, right? So it will print each item from the list, right? And then move to the next line. You can see println we have used, right? So similarly this is the for in loop, right? For in, right? Similarly we have multiple loops like while loop as well we have. Suppose here it will be running like whatever the size of this fruits array, it will run up to that time, right? But if we have some condition, right? Suppose if I have like I some counter and till I is greater than 0, this loop will running. Here suppose we want to do some logic, right? Suppose here we are just printing, but in the real world example maybe we want to perform some logic here, right? Maybe running some timer or anything, right? And then we are decrementing it, right? So if you see, it will run only till I is greater than 0, right? Or maybe if I put it 5 here, it will run till it's 6, right? 10, 9, 8, 7, 6, because it will only run whenever I is greater than 5, right? Like 6, 7, 8, 9, 10, like 5 times, right? This is the like while loop. Similarly, we can have do while loop as well. So let's reinitialize it, and suppose this is in the do while loop. Basically what will happen is code block will go inside the do block and while will be coming in the end, right? So this block will be executed at least once if this condition is true or not. But if you go here, this will only be executed if this condition is true. So this block only will be executed if this condition is true. If this condition is not true, it will not be executed any single time, right? But do while is different little bit. So this condition will be executed at least once whether this condition is true or not, right? If you see, it again printed 10, 8, 9, 8, 7, 6, right? And similarly we can have infinite loop as well. We can use the like this way, println, and if we want to just print the I, let's say, it will keep running until the memory of the programs become overflow maybe, right? You can see it will not break, right? But if we want to break it, what we can do is, suppose if I is greater than 5 or maybe like greater than 2, and let's initialize I here as well again. Okay, suppose if I is greater than 2, we will break it. Not greater than, actually, let's suppose if I becomes 2, we will break it, right? So we can use the break for breaking the loop manually, right? Still it's not breaking. Why? Because we have applied this condition I is equal to 2, but we have not applied some logic to change this value, right? So let's, after printing, let's reduce it. And now if you see 10, 9, 8, 7, 6, 5, 4, 3, up to 3, because when it becomes 2, it, suppose now whenever it will be 4, it will come here, it will print 4, it will become 3 here, right? If it will check this condition, it is not true. Again it will come here, print 3, then it will come here, it will become 2 here, and then here it will break. That's why 2 is not printed, right? So you can see this way we can use break statement, right? So there exist some variations of the for loops as well. I will show you. Suppose here it is only the item, right? But if we want index as well, how we can do that? And here we need to apply with index, right? So first item will be index, second one will be the item, right? Suppose index starts from 0. For it index will be 0, for 1, then 2, right? And if I print item at index, $index is $item. If I show you, you will see item at index 0 is banana, item at index 1 is apple, right? It's printing index as well, right? And suppose if we want to like skip something, like if we want to skip printing this, suppose if I apply index is equal to 1. So first, for the first index I don't want to print, I can do continue here. If you see, it printed at 0 and 2. For 1 actually it continue means it started the next iteration, it didn't came here, right? That's why we can use continue as well if we want to skip some iterations, right? Right. And if we want to break as well. Suppose if we want to like depending upon some condition we want to break it, we can apply break as well here, right? If suppose it is 1 or 2, like before the last we want to break, we can use break as well. So these are the break and continue as well. So we covered the loops and break and continue statements in this chapter, right? Let's move on to the next chapter, console input output. So basically what is console? Suppose whenever you see we are using the println and it is printing the data to the console. So this is the console where we want to test our app, right? This is the console. So for the console output, we are already using the println. So print and println, they print to the standard console output, right? But how we can read data from here? Suppose if user enter something and we need to get that here, how we can do that? That is the standard console input, right? Suppose let's print something first of all. Let's ask user to enter your name, right? Then whatever user will enter, we will get that. So for that we can use the two functions are there. So read ln or read line, right? We will discuss both of them, right? So first of all discuss this read line, right? This is the very old, this is available from the very beginning, right? In the Kotlin. But what happens is whenever user has reached to the end of the line, it will return null, right? So if we know in some cases input can be null, then we can use this. And another method is read ln. Whenever user will reach, whenever it will be like reading the content and reach to the end of the line, so it will throw exception. It will not return null, right? If you see its return type is nullable, but its return type is not nullable, right? So if in some conditions we are sure value will be present and it will not be null, then we can use this one, and this is available after Kotlin 1.6.0, right? And here we can print that name, whatever we will be getting from the user, right? We can ask hello to the user, right? Similarly here as well. Okay, let's try to run it now. So if you see, it's asking for us enter your name, right? If I enter coding ambitions, it will say hello coding ambitions, right? We printed it like there. So this has captured the input, right? This will read the full line. And here we are using the read ln, right? If you see, it's again asking for, suppose first of all it come here, then it stopped printing anything here, it came to this line. So then what we written there, it captured that and it came to here. Then after printing this, because it is println, it moved to the next line, it printed this line, if you see, right? Then it's again asking for the input. Suppose we enter here Kotlin, it will again print hello Kotlin, and then it will exit. Process finished with exit code 0, right? That is the like successful code, right? So this is the way like how we can get the input. So using the read line or read ln, right? And how we can print the output using the println or print, right? So this is the console input output. Now let's move on to the next chapter, ranges in Kotlin. So range is a basically set of values, sequential values, right? Suppose if we want some sequential values, we can use ranges for them, right? Suppose if we want something between two values, right? Suppose between 1 and 10, everything we want, so we can create ranges for them. Suppose we want 1 to 10. If you see, this will include everything 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with 10. This is the double dot range operator, right? And we can iterate over them using the for loop, right? Again the for item in range 1, right? We can print them. Item, right? Similarly, if you see after the in keyword, here we can use directly this one as well. If you see 1 till 15, right? It will run the loop from 1 till 15, right? Let's try to run it. So you can see first it printed till 1 to 10, then it again started from 1 to 15, this one, right? Let's comment it out. Suppose we want, suppose by default it will increment the this value by 1. So step, that is called the step. Whatever is increment or decrement happening, so that is called the step. But if we want, we can specify our custom step as well, right? Using this step we can specify, so it will increment it. It is starting from 1, then increment it by 2 instead of 1. This is the step, right? If you see here, it's printing 1, then 3, then 5, 7, 9, 11, 13, 15, incrementing by 2. This is the step. Similarly, we can have reverse ranges as well, right? So for that we can use the down to method as well. Suppose from 15 we want to go down till 1. Suppose here also we can specify step. If we will not specify, it will use the default step 1, but we can use step as well, right? It will start from 15 and start from end and print it in reverse order till 1 with a step of 2. I will show you. If you see, it started from 15, this one, then 13, 11, 9, 7, 5, 3, 1, right? This is the reverse range, right? So we can have until function as well here. For the incrementing range, we can have until function as well. Suppose if we, so what is the difference between until and this range? So it will start from 1 till 15. It will include 15 as well, right? But this will start from 1, but it will not include 15. 1 less than 15, like till 14, right? You can say if we run the loop till n-1, that kind of thing, right? And step will be the same. It can be applied anywhere in the range, right? Whether it is decrementing range or incrementing range, right? Then we can have this. Similarly, we can apply range on characters as well, right? Suppose we want to A till Z, right? If you see, char, and you will see it printed till 1, sorry, from 1 till Z, right? If you see A, B, C whole, right, till Z. So it applied to the characters as well, right? So these are the ranges topics. So we can have like simple range with double dotted, right? Then we can have the range with until. Then these are the incrementing range, right? Simple ranges. We can specify custom step as well. Then we can have like until with until also we can use with for the incrementing ranges. Then we can have reverse ranges, right? We can apply steps as well. Then we can apply these ranges on characters as well, right? So this one, when we use the until, this is called open range, right? So this is all about ranges. Let's move on to the next chapter, exceptions. So what is exception? So basically exception is an error which occurs during the execution of a program. Suppose we are running this program, right? And what happens is, maybe we are running this program, right? So basically what happens, we are using the index and index goes out of bounds for this array, right? Suppose size is 15 and index we are using the like 17, right? Then some issues, some error will happen in the program. It will not run, it will like throw some error. So that is called the exception, right? And how we can handle the exceptions? So for that we can use the try catch block, right? So where we know maybe some error can happen, that code will go here, right, inside the try block, and then we can catch that exception here. Like what is the error, what kind of exception that is, we can catch that here, right? Suppose if I print 10 by 0, right, it will throw exception division by 0, right? Exception e dot we can get message goes from these exceptions as well, right? This is a class, basically it provides detail about the exception, right? And for all kind of errors or exceptions, throwable is the parent class. If you see, throwable, right? So if I try to run it, you can see exception, and then it printed like divide by 0. This is the exception, right? This is the message of the exception, divide by 0. But if I do it with 2, it will not come there in the exception block, right? You can see it's not coming in the catch. That's how we can catch exceptions. And we can use multiple catch blocks as well, right? If you know, some multiple kind of exceptions can be thrown. Suppose if we know like arithmetic exception, these are some kind of exceptions, right? And suppose what we are doing is, let's say we have some data 1 2 3a, and then suppose, so basically by mistake, suppose we have inside this number we have written some character a, right? And now if we want to apply 2 int here, so it will throw exception. I will show you. It thrown like for the input string, right? This is the exception message, right? So if I print the exception directly only without the message, you see it will give complete detail like java.lang.number format exception, and this is the message. This is complete exception, right? Number format exception, because it is not able to convert this to the int because it has some character, right? So this is the how we can track the multiple exceptions, how we can catch them, right? It came in this block, but still if some kind of arithmetic exception can happen, that will be captured here. But if exception type is not this one, because this is a number format exception, so if you see, if apply that directly here type, so it will come inside here, it will not go in this generic block, right? You can see detail, exception detail, because exception type what is thrown from here, it is matched to this condition. But if it is not matched, then it will be like we can specify some general one as well, like exception, which is the parent of all kind of exceptions, right? It will eventually come here. Suppose if I specified the arithmetic exception here, but this is the number format exception, so this, after that it will check here like if it will be matching with this and it will not match, so then it will go to this generic exception, right? You can see, right? This is how we can use multiple catch blocks as well, right? And then we can have one finally block as well. It will be always executed, right? Whether there is exception or not, it will be executed, but these block will be executed only if exception type will be matching to them, right? If some exception is there, right, it will be always executed, right? Exception is there or not, it will be executed. Even if I like make it correct, then also it will be executed. There is no exception, but still it is executed, right? Then we can create some functions as well. Suppose if we have some function and from that I want to throw the exception, I don't want to handle it, then we can create our custom exceptions as well, right? Suppose we can create class, simple class, invalid input exception, right? So maybe you will not knowing about the class by this time, but still like you can just think of like class is the main basically entity which we can use to represent the real world entities, right? Suppose if you go here as well, if you see this is the class, right? So then we can extend the exception class, right? So don't worry about this, we will be covering this very soon in the coming chapters, what are classes, right? So we need to extend the exception class, then we can create any kind of our custom exception, right? And we can specify some message as well, we can pass that message here, right? And suppose if there we are calling some function, and suppose if we are checking some kind of validation, then we can trigger this kind of exception, right? So they make the like code more readable, like more clear, right? Suppose if we are invalid input we are getting in the validation of the form, right? And we are throwing simple exception, right? That does not make sense, like readability is not there, user will not understand like what is the error, right? Or even developer will not even understand like what is the exact issue here. But if we have specified this invalid input exception, it will become easier for both like developer and users as well. If it somewhere like throw exception in the app, user will also be aware like, yeah, it is invalid input exception, right? Name becomes like more readable, right? Then we can use the custom exceptions as well. To the next chapter, functions. So what are functions? Functions are reusable code components, you can say. Suppose sometimes we may need to like reuse the code at multiple places. So for that reusable code we can create functions. Then that can be reused at multiple places, right? Instead of writing the same code at multiple places, we can create function and then call that function at all the places, right? So then code will be only at single place, right? So this is the common syntax, like how we can create function, right? So fun keyword is used to define a function, then the function name, then this is the parameter body. We can define multiple parameters. For each parameter we can specify type as well, right? And then after this parameter body, so then we can have the return type of the function. Then we can have the function body, right, inside this curly bracket. So let me give you an example. If you see, I'm creating a function add. It is accepting two parameters. The return type as integer as well, right? So this type is also return type is also optional. We may have it or we may not have it, right? I will show you how. So here we can return, but if we have return type, then we need to return something, right? Whatever is the return type, that kind of data we need to return. So let's return the integer here, like adding these two numbers, we are returning the sum of them, right? Similarly, we can have simple function as well, for which we don't have any return type, right? So suppose here we want to just print something, right? Some message that will be accepting as parameter, right? And it is of string type. So you can see it is accepting one parameter and just printing the message. There is no return type, right? So we don't need to use the return keyword here, right, on the last line, right? And then we can have so if there is only single line inside the function, so we can omit the brackets, right? Suppose we are multiplying, okay, so if you see, we don't need to use any curly brackets here. We can remove that, right? That is optional then, right? We can use as well if we want to use, but they are optional then, right? And also return type, if it can be also inferred automatically, we can remove this one as well. This is like single line function, right? Then we can specify some default values as well, right? Some default message, right? This one can be for default value, right? And then we can have var keyword as well. So I will show you how. Suppose we have some with var function. Suppose we don't know like how many parameters we need of same type, right? So then we can use like var parameter. So var keyword. So this var keyword, then suppose this is the name of parameter and type is integer. So Here we can pass any number of integers parameters, right? As many as we wish, right? And then suppose we want to like sum all of them, so we can do that as well, right? So how we can access this? Like this provides it as array basically, right? So if you see, so where we can like apply the loop on this, right? Actually we don't need to print. Let's suppose we are summing it, right? And let's make it fair, okay? And then we can return its result, right? And its int type can be integer, right? Return, okay. Let's try to call them. How we can call them? Just the function name, then pass the parameters, like 2 parameters it's accepting, so we can pass the 2 integer parameters, right? So we can print them, right? Similarly we can for print message, simple print message test message, right? Then we can call multiply as well, right? Multiply, and then we can again have print message 2, right? So this have default value. If we have some default value, suppose if this is the parameter and for which we have already specified the default value, suppose for all the parameters we have specified the default value, so we can omit the, while calling the function we can omit like passing the parameters, then it will use the default value in that case. But if we pass, then it will use this one, right? Then sum with var. Here we can pass any number of arguments. You can see it will not complain, right? Let's try to run it. So if you see, first one is add 5 plus 6 11, then it printed this message. Then we have multiply 5 6 30, then we can have like default message, we have not specified any parameter. Then we can have this sum as well, 5 or 6 11 and 7 18 and 7 25, right? And similarly one more thing, suppose, yeah, so how we can pass the named argument. So name, we can use the name as well here while passing the argument. These are called named parameters, right? If you see, it will use that, right? So that's all about the functions. Let's move on to the next chapter, type checking and smart cast, right? So basically what is type checking, right? So as its name is implying, you mean checking the type, right, of something. So just suppose let me create one function, type checker. For any kind of object it will be checking the type, right? So any is like the object in the Java. So if you don't know about like any, if we have specified the type of some variable any, it means like we can pass the any type of parameter here, right? Suppose if we can pass the integer as well, string as well, right? Any is the super class of all the types actually, right? Check the type of this, right? So how we can do that, right? So here using the when clause, right? So we can do, here we can directly check. So when object is a string, so we can use the is keyword, right, to checking the type, right? And so what is this smart cast? So this is the basically type checking using the is keyword. We can use the if else as well, right? In the if as well we can check it. If you see, if obj is string, then do something, right? We can check it like this. And then inside this block, whenever we have applied this condition, similarly inside the if as well, so it is automatically casted to string now. We can use it like if it is string. So now Kotlin compiler is knowing that like, yeah, it's this string. We don't need to do anything here. We can assume like here compiler will assume, yeah, it is the string, right? So that is the smart cast. It's automatically doing the smart casting, right? It's automatically like we have type checked here, then automatically it converted this to the string. That is the smart casting, right? It automatically casted that variable to this, of which we are checking the type, right? So if you see, let me show some example as well. Obj is string and its length is, so I will show you now. It will, assuming it has string, so it will show like all the functions available for strings here. You can see is empty, toString, length as well, right, on the string. So because now it's assuming, if you see, length function and all the other things which we can apply on strings will be available here. So that proves like it have smart casted it to string here, right? This is the smart casting and this is the type checking, right? Then we can check for others as well. Int smart casted to int obj is int, right? Just before that, let me show you one example. So if you see here, we have type checked it with int, right? You can see length is not available here because it have smart casted it to int automatically, right? So that's it, and let's try to type checker, right? Suppose here we have passed coding ambitions, okay, and let's just print it directly, okay. And similarly we can check it with int as well. If you see, for this it printed like object is string, its length is 15, right? And then if you see, object is int, it have printed it like object is int. You can remove this block, okay. So basically you can see it, we are not returning anything from here, right? If we are printing it, so one important thing you can see here, basically if we are printing it but it is not returning anything, like, so what it will print basically, it's a very interesting thing. If you see unit, because if any function do not have any return type, then it means it have unit return type, which we can omit, we don't need to add, right? So yeah, that's it. That's all about this. Now let's move on to the next chapter, typecasting, right? So what is typecasting? So as we learned here, so it have, this is the smart casting. Smart casting is like compiler is automatically casting some variable to some another type, but typecasting is we are doing it manually, right? So I will show you. Suppose we have obj of type any, right, and we have assigned the string to it, right? And now suppose string, and we are typecasting it to string, right? So this is not safe, basically not safe casting, right? Why it is not safe? Just assume, suppose if object can be null as well, right? Suppose if it is nullable, it can be null as well, or maybe from somewhere it by mistake got set to null, right? So then it will like this is null, so it will replace it with null, and then it will try to cast null to the string, right? So then what will happen? It will throw an exception, right? Because what will happen is here we have specified the type string, but here it's converting null to the string, so it cannot convert the null to the string. That's why it will throw exception, right? And might throw exception. So this is the safe casting. I will show you how we can do that safe casting. So if you see, if I just put this as with question mark, so this is the safe casting. So why this is the safe casting, I will explain, right? So just assume, suppose this variable is of type nullable, right? And by mistake even we assign null to this, but what will happen here then? So if you see, it will replace this with null while checking it, so it will like check null as this question mark, so it means it will be able to check nullable as well, right? So what will happen is, if this is null, it will just return the null, otherwise it will cast it to the string, right? So that's why this is safe casting, right? So Kotlin compiler is smart enough. If you see initializer type mismatch, because why it's showing this? Because here we are using the nullable, but here we are not using the nullable, so we need to use nullable here, right? And if you see, now it will be shown no cast needed, because it knows this object has not been assigned null yet, so it knows, compiler knows. That's why it's saying like we don't need to do casting here, right? But just this is for explaining this thing, right? So this is, there are two ways how we can do the type casting, right? And one more thing, suppose we have, so how we can convert one type to another as well. Suppose we have this like 5 6 string. If we want to convert it to the other types, we can have multiple methods like toInt, toFloat, todouble, many methods are there. If we know like from somewhere we are using the string, but we need to convert that to int, we can directly use in the Kotlin toInt, right? It will convert this to the int, right? So that's all about this type checking, so type casting. Now let's move on to the next chapter, that is the extension functions. So what are extension functions basically? So extension functions are like extending this functionality of some class, right? Suppose we are using some third party library, right? So we cannot edit that library, right? So either we need to extend that class and create our custom class, right? But there is another way as well how we can do that. So we don't need to create another class, we can just create the extension functions on that class, right? It's pretty easy. Rather than like extending that class, it's better to create extension function if we just want to create one single method on that, right? So how we can do that, right? Suppose it's just like the simple functions, we will be defining the simple function, right? And suppose this is the greet function, it will be returning the string. So on whatever string we will be applying it, it will be like greeting that string, right? So hello, and this is the receiver type, right? Or maybe the class on which we are extending the functionality, right? So this is the receiver type, we call it receiver type on extension functions, right? So this receiver type is its value is available using the this keyword inside this, so we can use $this, right? And if we try to call it, suppose I am saying like we want to greet the Kotlin, let's greet the Kotlin. So println, it will greet the Kotlin, it will print hello Kotlin, you can see hello Kotlin. So basically this is the like extension function we have created, because on this string we don't have any kind of like greet function. Otherwise how we would have done it if extension function were not available, right? Either we can have like accepted it as argument and then returning this, or maybe we can, if we want to, without we wanted to create without the parameter, then we would have extended the class and then defined this method, right? Inside this class, string class, we would have like used this for getting the current instance of that string, right? And similarly, we can define some other extension functions as well. So just for example, so if we want to like make the checking of is even or odd, right? It become pretty easy here. Instead of passing the argument, we can directly apply that. So from the readability purpose, it's like pretty cool, right? So here again, this, because value will be available using this keyword, right? And it will return boolean, right? So if you know, we can check with 1 is even. If 1 is even or not, it will print false. 1 is not even, that's fine, right? So we can check it with 2 as well. It should print true. So these are the extension functions, how we can create the extension functions, right? We can create it on any class, any custom class as well, right? If we want to like, after using third-party library, we want to extend the functionality on some, like we want to use few fields and want to like create some logic like manipulating those fields and calculating something, so we can create these extension functions on those classes, right? So that's all about extension functions. Let's move on to the next chapter. So next chapter is classes, objects and constructors. That's pretty important topic. So I will explaining it like what is the class basically. So class is like if we want to represent real world entity, right, in programming, how we can do that? Suppose if we want to represent employee or user, how we can do that? Because we need some fields as well for that to store data about them, right? Suppose like for an employee, we may have like the name, age, right? So address, these things. Similarly for user, we can have these things. So where we will be storing them? Usually we use classes them to store that data, right? So how we can create the classes basically? We can use the class keyword, then the class name, right? Suppose person, right? This is the class, and few more things. So inside the class, we can specify like which field we want to expose and which field we want to keep private. Those that can be done using the visibility modifiers, right? By default, class is public and final, right? So suppose I want to create private class, we can use the private keyword before the class, but by default it is like it will be visible everywhere basically, right? Internal, in the same module it will be available everywhere, right? So suppose on the person we can have like name, so we can define like private val name, that will be of string type. We can give some default value, right? Similarly we can define age as well, right? Age can be of int type, right? If nothing is specified, we can make it 0, right? These are the properties, right? Similarly we can define methods as well on the classes, right? So why do we need methods? So just suppose we want to like perform these some operations on these, like we want to get these values, like how we can do that? Because they are private, we cannot directly access. So either we can make them public, but we don't want to make that, because so then everyone will be available to modify them as well, right? So but we just want to make them private. After setting them, only like who is authorized to do that, who should be able to modify these, right? Suppose just print info, we want to print, so we can just use this simple method is like just simple functions we can define inside the class, right? If we don't define any modifier, that will be public, right? Everyone can call that function on the object of this class, but if it is private, it can be used only within the class, right? Suppose here we will be printing the name and age, okay? And so yeah, this is about the properties, methods, right? These kind of things we can do. This is the simple class, how we can do that, right? And similarly, if you see the same class, we can define in another way as well, right? That's where we will discuss about primary constructors. Suppose here after the class name we can use these round brackets, and then here we can define these properties, right? So maybe we can name it person2, right? So if you see, now properties we have already defined inside the constructor. So this is the primary constructor. We call it primary constructor, right? And then along with primary constructor we can have init method as well. So basically init will be like called when the object of this class is created. Suppose from these variables, when we are creating the object, just before after that, like just immediately after that, we want to like perform some calculations or we do something with these variables, we can use the init block for that, right? We can say person is created with name equal to name and age equal to age. So we can print this message, right? I will show you example as well. So then this is the primary constructor, right? So because if we want to perform some calculation or some logic with these, so we can directly use the init block them, right? And now we can have second constructor as well, right? So what are the second constructors? Suppose let's name it person3, right? So this block will be there. So just suppose we want, like in some cases we want like only few fields to be initialized, we want some default values maybe, right? So or maybe just we want to like, suppose we have multiple, a large number of parameters, like, but suppose what we can do is for few things we can apply default values, right? Suppose for this we have default value, but if for this we don't have default value, right? But if we want to create this constructor and just for if for some parameters we don't have default value, we need to specify both of them. But like how we can do that using the secondary constructors? So here we can just specify whatever value we need, only that value, not the all values, right? Just suppose we need name, right? We don't need to specify val keyword here basically, right? So that we need to specify here. Because why we need to specify val keyword here, if you observe, because this will declare these properties inside this class as well. They are not just parameters, they are the properties of this class. That's why we need some val or var with them, right? Suppose now this is kind of similar to like method, just simple method things, like, but just they are the constructors. So while creating objects we can use them as well. Constructor keyword we can use for creating this secondary constructor, right? Or other way can be like, if we want to create the same thing from some other class which is something similar to this, like some fields may be missing, but some fields we need to, like these fields are there but some extra fields are there, but we want to create this object from that class, right? Suppose we have this person2, from person2 we want to create person3, so then also we can use this constructor, secondary constructor, right? One important thing is we need to extend this secondary constructor will be extending this, so that is the like primary constructor, they will be extending the primary constructor. That is the must condition while creating the secondary constructors, right? So if you see now, from these fields we want to initialize and now why it's saying, because they are val type, right? We cannot modify them. Now we can do that, right? Name So if you see on the person2, just suppose like we make these public ones, right? Or maybe we might have some methods as well, forgetting them. We can do anything, right? That depends upon our use cases, right? Name, right? So this is another way of creating the constructor. And one more thing, we can have only one primary constructor, only one, right? But we can have any number of secondary constructors, right? So let's just try to create the object. How we can create objects, right? We don't need new keyword here. Like in other languages, maybe if you are aware of, we may need some new keyword to create the object, but here we don't need. Just use the class name and its properties, and we can omit this. Don't pass like any properties when we have some default values for the properties, right? Suppose for one property we don't have any default value. So first of all, it will be saying like, yeah, we need to initialize it, or maybe we need to make it like lateinit or nullable, right? That's why we have initialized them, right? So on the person dot apply, here we can use the apply function as well here, or maybe we can directly do, just ignore apply as of now. I will be covering that in the upcoming chapters. What is the apply? So these are scope functions, don't worry about them. So we can use the simple way, right? If you see, so these are private, so we cannot set them publicly. Either we need to define some functions for setting these values, or we can make them public, right? So for the sake of this video, we can make them public, right? So here we can set name user1, right? And if you see now they are val, we need to make them var to make them mutable, right? And then we can have age. Similarly, we can create object passing these values directly here as well, right? But when we can do that, if you observe, when we can do that, here you cannot do that. Why? Because in the primary constructor we don't have any value here, right? So you cannot do that here. You can do that with person2, because we have these values inside the primary constructor, right? So here you can directly pass these fields, right? User2 and age might be like 18, and then we can have person3, let's make it person2, person1, or maybe let's just person, right? So for person3, now if you see, we can have these constructors as well. I will show you how we can use them. So this is the default constructor, primary constructor, right? And now just suppose if we want to create it from person2, we can use this secondary constructor for that, right? You can see. Now just for example, let's test it. Print info, maybe 4 as well, right? If you see, person is created. This is the like init block. Whenever we created the object, so init block is called then, right? Similarly for second one, right? This one. Similarly for third one. So basically they are for second and third one, right? For these. For the first one we don't have that init. We have not used there, right? These are for person2 and person3. We can change it for like better readability, and let's try to run it again. If you see, person2 is created, person3 is created, and then if you observe, what happens is, now why it printed this one, I will show you how. So if you see carefully, this person3, from this person3, this constructor, whenever this is called, right? So then what happened is like, if you see, it called this. So this means primary constructor. So whenever this is called, so init will automatically be called with default values, right? Then later on it modified these, right? if we add this function with println, it will move to the next line. I will show you. Output will be better for readability, right? 1 2 3. Okay, if you see now, these points are clear, and this one was because this one was called because we use the secondary constructor, and that is then calling the primary constructor, and then that primary constructor is like whenever we are creating the object, init is being called, right? So if you see, first call printed this, second call, third and fourth will be printing the same, because this second and fourth will be the same. Why? Because we created that from this same person 2, right? So for this we can print user 3 now. It will print user 3 if you see. Yeah, these two values are same because we created this object from person 2, right? So this is all about like classes, objects, constructors, primary constructors, secondary constructors, init, method, right? All about these classes. Let's move on to the next chapter. Inheritance. So what is inheritance basically? Suppose we have some class, right? But we want those functionalities in another class, but in another class we want some extra functionalities as well. Suppose we have some class which have some its own functionalities, plus it requires some functionalities from another class as well, right? So then we can use the concept of inheritance. Inheritance means one class is extending the another class, right? So how we can do that? So by default, if you see, you might be not knowing about this. So by default, all classes in Kotlin are final. Final means we cannot inherit from them. So how to inherit from them? That's question. So that we can do using the open keyword, right? Similarly, functions and properties are also final by default. We cannot override them. To make them overrideable, we need to use the open keyword. So let me show you an example. Suppose we have one vehicle class. Just assume, right? We have one vehicle class, private val name. It will become more clear to you what is inheritance basically. Then for vehicle, we may need the like name of the vehicle, speed maybe, right? Or other things as per our need we can add, right? And suppose it have one function, display info, anything like displaying some info about the vehicle, right? Maybe like it will be printing the vehicle name, vehicle name is like dollars dot name, right? Or then we can have speed, right? And now just assume car is also a vehicle, right? But car can have some additional features like number of doors, right? So number of doors, but bike cannot have doors, right? So but bike can have name and speed, car can have name and speed, but car can have some additional features as well, right? That's where concept of inheritance comes, right? So we can create one more class here, that is the car, right? So what will happen is, because these two fields are the base, we can define one base class. Basically this is the base class, right? So parent class you can say. So now these two fields are defined already there. So while we will be extending it, suppose I am extending it, and if you observe here, it's saying like type is final, cannot be extended. I make it open. Now that warning is gone, but now it's asking for providing these values while extending it, right? Because that is the primary constructor, we need to provide these values. If suppose we have not defined anything there, right? So these three values we can accept from here. And one more thing, just suppose we have num of doors, right? That is int again. So these two we need to pass in parent as well here, name and speed, right? Okay, so if you see, and now func keyword. So because we need to add override, we can override it, right? By directly, suppose if some method is defined here as well and we want to define in this child class as well, we cannot do that, right? With some different parameters we can do, but with same parameters or signatures we cannot do. We need to override that if we want to reuse that, right? So we can override this, but still if you see, this method is vehicle is final and cannot be overridden. That's again the same concept. Methods are also final by default. We need to make them open to be overridable, to make them overridable, right? So if you see, we have override that method and we have extended that class, right? But this one we can omit as well. If we don't want to override, we can remove it as well. Now these two informations are already printed there, so we don't want to repeat that code here. What we can do is we can call this super keyword is used to access the instance of the parent class while we are extending some class, right? In our this class car class, how we can access this instance of super class, its parent class vehicle, using the super keyword, right? So this display info these two items are already printed there, so why we should print them here? We should not, right? So we can directly call this method. So this method what will do is it will print these two informations, right? Then for the remaining informations we can print here, right? Num of doors, how many? $, num of doors, or we can use this as well, and then anyway we can do, right? So similarly we can create the bike as well. For bike we can directly extend that class. We don't need to add this extra field, right? We can extend the vehicle class, right? And now how we can create their objects, that's pretty easy. Again the same thing we'll be doing. Oops, that's the printing error. Car, and we can pass Toyota, and then we can have speed like 2 kmph, then we can have number of doors 4, right? Then we can just display info, right? If you see, these two are printed from the parent and this one is from the child, right? So that's the concept of inheritance, right? How we can extend the classes. And one more thing, we cannot extend multiple classes, right? We cannot extend multiple classes basically. So only one class we can extend. If you see here, we cannot extend one more class. That's the limit of this inheritance in Java and Kotlin both, right? For that we use the interfaces that we will be covering in the another chapters, right? So that's all about the inheritance. Next chapter, interfaces. So what are interfaces? So basically they provide the abstraction, right? So in interfaces we can define some methods and properties which our classes can implement, right? So sometimes like if we want to decouple the decouple the implementation and the abstraction things, we can use interfaces there. Why? Because all the abstraction things will be defined in the interfaces and all the implementations will be done in the classes, right? It makes unit testing easier and also it decouples the, as I said, implementation and abstraction, right? So one more thing, classes, if you see in the, as I was telling you in this chapter, so in inheritance one class can only extend one class, right? So cannot extend more than one class. But if we want to extend more than one class, then what should be the way? So basically we can define interfaces. We can define two interfaces, right? So then it can implement more than one interfaces. but it can only extend one class, but it can implement more than one interface. That's where interfaces are useful as well, right? So how we can create interfaces? Using the interface keyword, my interface, right? And then we can define abstract method. So this is abstract method. It means we are not providing any body for this, right? Similarly, we can define concrete methods. Concrete methods means we are providing the implementations, right? Suppose we are just, for example, we can just specify like this is a concrete method, right? Actually, this feature, like earlier in the interfaces, we were not able to like provide the methods with implementations, right? So basically this feature is unique in the Kotlin actually, right? And one more thing, suppose in the Java, it was not available before the Java 8 version, right? Before that we cannot define the, like we can just need to define the abstract methods there, right? And if we needed to define some concrete methods as well, like method with implementation, then we needed to use the abstract classes. But in Kotlin we can directly use the interface. It can include abstract methods as well and non-abstract methods as well, right? And in the Java, as I was saying, like before Java it wasn't possible, but after Java we can define some default methods in the interfaces as well, right? Let's come to these interfaces back in Kotlin. So suppose now we want to implement, or maybe let's define some properties as well, right? Suppose this is a simple property, right? And if you see, we cannot initialize properties in the interfaces, right? It means it cannot include the state, right? It can just include the properties but cannot include the field. Fields means which the properties which include some data as well, right? We can initialize some data as well there. Those are called fields, but here we can say these are properties, just properties. They have no value or no state with them, right? And similarly, if we suppose if we want to provide some property with some default value, we can do that using the getter, right? So this getter and setter methods, we will be covering it in the like coming chapters. Don't worry about them, right? So as of now, you can just assume this will provide its default value, right? Suppose now a class implements that. My class implement my interface, and if you see, whenever I use this extend, suppose how we can extend another class using the same colon. Similarly, implementation is also done by using this. In the Java we use the implements keyword for this, but in Kotlin it's the same. Extend and implements, they are the same, right? And if you see now, it's saying my class is not abstract and does not implement abstract method, right? So it means we need to implement that method, implement members, right? So these we can add them, right? And here we can just add whatever implementation we want to, right? And here we can directly define its default value, right? We can define like anything, right? Then creating object, it's pretty same, right? We can create that easily. Now let me give you one more example. Suppose if we have two interfaces, right? Suppose let's just copy this and let's add one more interface, right? My interface 2, right? And suppose it also have this concrete method, right? And this is the abstract method, right? And if suppose one class, we have one class, suppose let's just copy this, and this class, suppose we want to, my class 2, implement both interfaces, right? So we can use the comma there, and then the same way will be used like column, then the interface name, then if there are multiple, we can use the comma and then multiple interfaces, right? And if you see, it can say cannot infer visibility for concrete method. Why it's saying? It's asking class my class 2 must override a concrete method because it inherits multiple interface methods for it. So basically both interfaces. So if you see here, we have just added the abstract method but not the concrete method, right? So this abstract method, this is also common. So let's remove this, right? And now if you see for interface 1, let's implement this property as well. And then if you say, it says must override concrete method because it inherits multiple interface methods for it, right? So if some same method is defined in both interfaces, if you observe this concrete method, same method is defined into interfaces, then we need to override that as well. And here we need to use, suppose if we will be calling the super class directly super dot concrete method, right? We cannot do that because this method, concrete method, super means it's super, either this or this, right? Any one of them, because and both of them have this method. That's why for the super it will be considering both of them. But if there will be unique method which is inside this only and not in this, then we could have used the super directly. But here we need to specify type parameter of which class we want to use the super, right? You can see. So this way it can implement both. So similarly, if you see, this is the multiple inheritance and this is how we can implement the interface, and after defining the interface, right? And this is like how we can implement the multiple interfaces in the same class, right? And just for testing, let's just create my class obj dot, let's call abstract method, and then obj dot concrete method, right? And then let's print bj dot, let's suppose we print property and property with default as well. And if you try to run it, so obj will call, because my class is implementing the my interface, right? So it will provide these implementations. For abstract method, it overrided that, right? And it provided this implementation. But for concrete method, it's using this super method automatically, right? It will be automatically available, right? And then default value, this is for this property, right? If you see here, property value, right? And this default is for default property with default, right? Another property, this one, right? So what are the advantages of interfaces? Let's repeat. Suppose one thing is like it provides the complete contract of what we want to do with the like our logic, right? Or functionality. And so what are the benefits of that? Basically it decouples the implementation from the like abstraction thing, right? And then what we can do is it becomes easier to test the interfaces. We can just, for testing, we can just provide its implementation with test class, right? Then it becomes easier to test, right? And another useful advantage was like it provides multiple inheritance, right? Which was not possible with classes, right? So that's all about the interfaces. Let's move on to the next chapter. If you see, let's Let me show you this example as well. My class 2, right? So if you see in the concrete method, it will use, suppose method 1, yeah, suppose if you see I have added the my interface here, so it will call this concrete method but not the second interface, right? If you see, let me run it again. This is a concrete method 1, so it called it from this one because we have specified the type there for the super, right? Which super, like which parent it needs to use for this method, right? So that's all about this. Let's go to the next chapter. So property getter and setters, right? So properties in Kotlin can have the custom accessors, means like custom getter and setter methods, right? To control the access and modification of the property, right? Suppose when we are accessing it, if we want to do some kind of logging, if suppose we are updating it and we want some logs, those kind of stuff, right? So we can provide the custom getter and setter methods, right? How we can do that, right? Suppose I have one class person name, let's define it inside, right? Where name, it is of string type, right? And its default value is, let's say, just coding, or maybe some name, maybe we can add light. And using the get this method, right, we can define its so this is the custom getter. While we will be getting this value, right? Suppose I need this value, I want to access from the person object, I want to access this value. So this get method will be called. It will not provide this directly, right? It will call this, and here inside this method we can use the field, right? This is the backing field, right? It is just need to control its internal representation, right? Suppose inside the getter or setters we can use the field to access the value of this property, right? The field keyword, right? And because this is the single line logic, so I don't need brackets here, but still if I want to add, I can do, and then I need to add the return, right? I can do it this way as well, right? Or directly this way as well, because if directly I explain this in the functions using the equal, then we can just add, if it is single line, that will be returned, right? Automatically. And similarly, I have, suppose I want to define custom setter as well for this. It will be accepting one parameter which we can give any name, right? Suppose, but ideally we give it name like value, right? And so if you see, if we want to set so whenever this, we will be updating this, right? Suppose like person dot name equal to, we will be updating it to some other value, right? So this method will be called, this is the custom setter, this is custom getter, right? And then we can have this one custom setter, right? Just assume like if we are calling it while saving it, suppose during saving as well, suppose we want to apply some kind of operation here, like just suppose like we want to save the data in the uppercase, right? Or we want to save data in the lowercase, so we can then apply that logic here. Just suppose we want to save it in the lower cases, right? Or maybe capitalize first character, any logic we can apply here, right? Suppose we will be setting something, suppose I set it like John, but what it will be saved here, because then it will come here, this value will be including the zone, right? It will be containing the zone value. On that zone it will be applying lowercase, so that will become the j will also become the small, right? These are the custom getters and setters, right? And suppose we have one more variable, that is the age. Suppose on age, if I want to, like, while setting the age, if you want to directly apply some validation here, I can do suppose if it is greater than 0, basically we can set it, right? Else what we can do is we can throw exception, or we can print anything if we wish. That depends upon ourselves what we want to do. If I space, this is the illegal argument exception, that makes sense to return here, right? Because this argument is not legal. So we can specify this, and inside this we can just show like age cannot be negative, right? If you see, because we are having the setter, so setter we can only apply if it is the var type. On var type we just can apply the getter. So now let's show you one example of creating the object. Suppose I have created some object here, even let's say just I have not passed anything here, and suppose person dot, if I update its name, right? Or if like directly update the age, let's say update the age, so it's 25 here, age is 25, so it's valid, it will update, right? If I print after that, if I print it person dot age, it will print it correctly. I will show you. Redundant, actually we have viewed this class elsewhere, so what we can do is, let's say just define the person 3. Okay, person 3 is already defined, so let's just name it person 4 maybe. Alright, no worries. And if you see, it updated it to 25, right? But just assume if I set it 0, what will happen? On 0 it will work fine, sorry. We need to set it negative, right? If you see, while this code will be called, it will throw illegal argument exception, that is age cannot be negative, which we have specified, right? So validation will be like immediately applied it while we are setting it, right? That is like very great feature of these custom setters and getters, right? And similarly, suppose yeah, let me show you one more thing. Suppose I have set the person dot name John, right? Setter is already covered there. Let's apply the getter logic here. So suppose I have set the name John, but while I will be getting it, suppose, sorry, let's I set up it in small letters, right? But if you see, while I will be printing it, like I will be getting it, so while we are setting the value here, while we are setting the value, like updating the value, then setter method will called, right? while we access the value, getter method will be called, right? So if you see, you will observe one thing here. If you see, I set it like in the lowercase letter, but I received it as uppercase. How it happened? If you see, while I'm getting it is converting it to uppercase here, right? That's the power of getters and setters in Kotlin, right? That's all about this getter and setter. Let's move on to the next chapter, data classes, right? So what are data classes? As its name is implying, the classes which will be holding data, right? It's pretty easy, right? So, but what are the uniqueness? So what is the uniqueness of the data classes, right? Suppose in the Java, if you know Java, maybe, or if you don't know, I don't know, like if you know, but then this thing will apply to you, what I am going to tell you. So before the records were introduced in the latest editions, so before those in the Java, if we need to define data classes, we need to apply equals, toString and hash code, these methods, right? So we needed to implement these methods manually, right? But here in the Kotlin data class, we don't need to do anything that kind of stuff, right? Because it automatically creates those methods once we use the data keyword before the class name, right? So let me show you one example. Data class, this is the way of creating that. And suppose I want to create the name string, then let's say age int, right? In the constructor I am passing these properties, and if you see, if I don't specify well, it will show error, right? So we need to specify either val or var, right, with the data classes properties. So this is the data class now, right? So if you see, if I create one object here, suppose Alice and 30, and if I create one more user here, and if I compare them, right, let's name it user 1, it will print true. How it is printing true? How it knows that they are equal? Because it have automatically implemented the equals method for this, right, and hash code method as well, right? But I will show you one thing. Suppose if you see, when you type the override, you will see equals hash code toString. But still, if you want to provide your own logic, you can do that as well, right? Hash code toString, suppose in the toString, if you just want to print logic according to your own, right? I will show you this method, just wait, I will show you. Just suppose, let's first of all showing you printing this object. So what is the default, how it is toString is implemented default. So in the toString default implementation, it's printing it like this. But if I override that method, what it will print, whatever I will be returning here, right? Let's say I just say name is the name, comma age. If you see, now it will not print it like this, it will print it like this, because I have overridden that. But this is not needed, this is very rare cases, in very rare cases we need this, right? Because otherwise it provides all these implementations automatically, right? If you will override, if you type, it will show you every method, toString equals hash code, all these methods it automatically provide you, right? And one more few important things. So you cannot create data class with, if you see, without any property. At least single property is required, it is not allowed. If you see, it will say data classes must have at least one primary constructor parameter. right? And second thing can be data classes cannot be abstract, open, sealed or inner, right? If you see, so it is not allowed to extend, right? Why? Because it cannot be open. We cannot extend one data class from another data class, if you see, right? And that was this point. Then it also provides us one more method. Suppose user1 dot copy. Copy method is also created. For each class, we can copy everything. Suppose from this user1 we want to create one more class, user3. It will copy everything, right? And if you print user1 and user3, you will see true because it copied everything, right? But if you try this, you see it is false because triple equal checks for the references as well, right? But double equal just checks for the content, right? True, false, because references are different. This is different reference, this is different reference, right? And one more thing, so it provides us component methods as well. Println, suppose if you see from user3, suppose I want to, if you see component 1 and 2, it provides component method, like how many properties are there, that many components it will provide you. It will print first property, it will print second property. If you see, it printed the Alice, then it printed the age, that is 30, right? And so that's all about the data classes basically, right? Suppose sometimes what are the use cases? Suppose when we are calling the like APIs, or we are creating some real world entities there which we need to like make the comparable as well, right? Or suppose we are saving data in the database, for that we need to create class. For all these kind of stuffs we can create data classes, right? Because we don't need to like implement any of the toString hash code or equals method, right? Let's move on to the next chapter. Destructuring declarations, right? So destructuring declarations, suppose we have one declaration, we are destructuring it. Destructuring means unpack. Something is packed. Suppose we have one box, it has 3 items, but we want to unpack it and get all those 3 items in 3 different containers maybe, right? So that is kind of destructuring declaration. Just suppose let's copy this method actually. But if you see now, suppose I want this, after the val we can apply these brackets, then suppose it has like 2 properties, right? Suppose I want name here and age here. If you see, and directly assigning this, so from this it will be creating 2 variables, name and age. If you see, if I print name and age, Alice and 13, right? And still one more thing, so if you see, if I don't want, suppose I just want one component, you can remove. If that is not needed, you can just use the underscore for that, right? But if you see, if by default we have just one parameter, right? Suppose if we are getting the only one destructuring variable, right? We are creating one destructuring. By default it will just use the first one there, right? You need to remember. So if you don't need anything, you can just use the underscore for them, right? That's pretty cool feature with data classes, or it can be applied on data classes Mostly it applied on data classes, right? It can be applied on pairs, triples as well in Kotlin, that I will be covering in the upcoming chapters, right? That's all about this. Let's move on to the 24th chapter, Enum classes. So enum classes are used to define a set of constants, right? So enum classes can have properties and methods as well, right? They cannot be abstract, open and sealed. These are most important properties. We cannot extend enum classes, it means, right? We cannot make them abstract as well. We cannot make them sealed as well, right? So whenever we have a set of constants, suppose we know like directions, suppose we have directions. There can be 4 directions we have, right? And we know that thing, like, so there can be only 4 directions, so those are like kind of fixed, right? So we can create enum class for them, right? Direction, right? And it can include, just suppose, degree, right? And if we define north 0, suppose, and then we have east 90, south 180, and we need to use comma here, right? North, east, south, west 360, right? And suppose we want to declare some method as well here, right? You will observe one thing. You see it will showing you error here, but if I remove this, it will not show here error. So if there is no function defined, we can just let it as it is, but after the last value. Otherwise we need to add semicolon after the last value if we want to define the methods there, right? Suppose direction is name and degree is R. So name can be used to get its name, right? Literal values, right? So I will show you one example. Suppose direction dot east. If I print it, you will observe direction dot description. Suppose I'm calling this. If you see, we just don't need to print this. We need to return actually if we want to print it. Right, if you see, direction is east, name is like whatever is the enum, it creates the constants from them, right? Literals. For each entry it creates name, if you see, right? Name of the enum constant, exactly declared it in the declaration, right? Similarly we can have ordinals as well, right? I will show you. So this is the property which each enum is holding, right? This is its name, right? So I will show you. If you observe here, direction dot name, we can have ordinal as well. That is the like kind of like its number starting from 0, 0, 1, 2, 3, like ordinal, its number in the list, right? Its position, you can say. And then suppose we want all values of the enums, right? So we can call the entries function for that. So this is basically entries function is available only after Kotlin 1.9.0, but before that Suppose if I want to do that, how I will do that? Using the values. But after Kotlin 1.9.0 we can use the entries. Before that we will be using the values. If you see, first that one called north, east, west, south, west, then it called this one for values, north, east, south, west, right? So that's all about enums. Mostly we need enums whenever we need some fixed set of constants, right? Let's move on to the next chapter, sealed classes. So what are sealed classes? Sealed classes are basically they restrict class hierarchies, right? So suppose we know like we have one class and we can have similar 3 or 4 more classes similar to that class, right? And we know it should be like only 3 or 4 similar classes should be allowed to extend that class, right? But not more than that, like restricting the inheritance kind of thing, right? So suppose I have like one sealed class and I can have 3 or 4 more classes like that, so I can create sealed classes for that, right? Let me show you one example. So basically suppose if I am on the like loading the some implementing some logic in the like Android side, right? So suppose our UI, suppose in UI state, what can be the state? Suppose whenever we will be hitting the API, it will be like loading, right? At that time state will be loading, we will be showing some loader. After the API is successful and we got the response, it will be like loading will become false and we will be getting some data there, right? Success. And if it is not successful, then we may get error as well, right? So here if you see, UI class can get 3 states: loading, success, error, right? So here we can use the sealed class, right? So let's say we have one sealed class, screen UI state. So here what we can do that. So what we can do is like suppose we have object loading. So this is the loading state and every class will be the subclass of this, right? Suppose this is the sealed class, main class, and then of this type we want one more class that is loading, right? And we can have success as well, but with some data, right? Data, some data, and I will be creating this class here. Suppose we have some class here, some data, right? And it will be maybe holding some data, right? Let's say name, just for example. It can be anything, data from the API, right? It can be. So if you see, we can have, so object, when we use the object keyword, suppose it is not holding any data, then we can use the object. But if it is holding some data, we can define the data class, right? And third one we can have is error, right? Error can also hold some data, that is maybe error message, right? We can assume it will be holding some error message, or maybe it can be holding exception as well, anything as you want. Like this is also extending this sealed class, right? So now this sealed class, that is the screen UI state, we know it has only 3 types, subtypes you can see, right? And these are all the sealed classes you can see, right? So basically this sealed class has these 3 instances, subclasses, right? And let me give you one more example. Suppose we create just one test class and that is extending this screen UI state. Right, so this is the example of sealed class, right? Because now we know we have screen UI state and that can have only 3 states. So you might be wondering about this, like similar to the enums, right? But what are the differences, right? Suppose I will be coming to that point, differences between enum classes and sealed classes, right? So here if you see, suppose I have some function. Let me define one function just for understanding this. Update UI, right? And it will be accepting the, let's say, screen UI state, right? And depending upon the screen UI state, we can use the when clause here, and when screen UI state is loading, right? Here we can show, here I'm just printing, but you mostly in cases of like UI thing, it will be the some UI here, like some loader, we will be showing some loader, right? And in case of success, we can show some data directly here, right? State dot data, right? And then we can have error as well. In error we can define error message, we can use the error message, sorry, right? And suppose, if I will show you example, suppose initially we called the API and I passed the state as loading, right? Then I added some delay here, but to add delay actually it is suspend function. Let's skip this as of now, because you might, at the time you might be not knowing about this delay, right? So for example, just let me show you, like suppose here we got some data, right? After some time you can assume like here there will be some delay, right? Suppose this is the API call, and then suppose we will be getting some data. Here we can just define anything, right? Dot state, and we can make it var type, right? Oops, it's accepting the some data actually. I'm just passing the string. Let me show you. So if you see, first it showed loading, then we got some data and we displayed the data. Even I can show you like dot sleep maybe, then it will become more clear to you. If you see loading, suppose for 1 second it was loading, then we got some data. Suppose we are calling the API here, then we got some data. That kind of logic can be implemented using the sealed classes, right? Now let's come to that point, difference between sealed classes and Enum classes. So if you see, it is also related to, like suppose we have some fixed set of values, then we can use this. Like suppose we have 4 values, we use the Enum. Similarly we can have sealed class as well, right? Suppose we have 3 states, we can have then sealed class, right? So you might be getting confused here, right? Which one to use when, right? Suppose you will understand the difference here. If you notice, each of these subclasses, they can hold different type of data as well, right? You can see it is holding some data, it is holding some error message, right? And it is not even holding anything, right? But here if you see, every value of this Enum, they hold the same kind of data, like only degree, right? This degree, they only can have this degree, every other one, but only this value will be different, but they only can have this data. But here if you see, we can have something without no data, we can have something with different data, something else with another different data, right? That's the main difference between them, if you see, right? Let's move on to the next chapter, lazy versus lateinit, right? That's pretty important topic. So if you see, in the beginning I explained you like lateinit, right? Suppose delayed whenever like that is the like non-nullable variable that we were expecting will be initialized later, right? So similarly we can have lazy as well, right? I will show you the difference between them, right? Suppose we have some class maybe here, right? Let's say just remove it, right? So here suppose I have lateinit var user late init, right? Suppose there is some variable that is user, And just for example, let's assume we take user class which we defined earlier, right? Suppose this is some, in the data classes we defined this user class. Suppose it is of type user, right? Lateinit where, if you see. And suppose another one we can have user lazy, right? It is also of type user. And here we will not be using the lateinit, and we cannot use the where as well. But lateinit can be used only with where types. It cannot be used with val. If you see, it cannot be used, right? Similarly, lazy can be used with val types, right? And we use by keyword for delegation. This is actually inbuilt delegation, right? So delegation we will be understanding about that topic in the coming chapters. But till then you can understand like it is the delegation. It means it's this thing. Its implementation will be provided by this block by lazy, right? And here I can provide some user, right? Any value of the user, right? Suppose coding and age, suppose 4, just for example, right? And this will be initialized later, but this will be initialized whenever we will be needed this first time, right? And suppose we have here right. Let me create its object lazy versus lateinit, and here object dot lateinit. This one I am initializing here, right? We can define it name one anything, right? And that will be initialized whenever we will be using that first time. Suppose I am using it here. Suppose I need to use that, right? This is mostly needed in cases, suppose when we have some database classes and we want singleton instance and we just want to initialize that only when that is needed, right? We can use the lazy in that case, user lazy, right? And let me print that. It printed the lazy thing, and we can here print as. So here I will show you one more thing. If I print here obj dot user lateinit, and if I print it here as well, you will see some exception there. You will see lateinit property has not been initialized. That I explained whenever we learned about lateinit varies, right? So basically, what is the difference? Whenever we don't know like what value can be like at the time of class creation, we don't know like what can be the value of this variable, then we can use the lateinit. But when we know the value, but we only want to evaluate that lazily, right? Suppose later on, whenever that will be needed, only then it will be initialized, right? And also for this class only singleton instance will be created, right? Whenever next time it will be needed, it will be providing the same instance to you, right? Every time, right? So this one we can mostly use like for Android views. If you will be like learning about Android, sometimes we need to like initialize views later on, like find view by ID, or maybe, or depending upon some logic there, we need to initialize some things later on, right? But this one mostly whenever we need singleton instance, and that is only needed whenever that will be used, right? Only at that time. If suppose that is used later on time, so that at that time, suppose what will happen is whenever object of this class will be created, this will not be initialized. Suppose it will be needed very later on, right? So why we should initialize it at the same time, like when we are creating the class object, right? That does not make sense. So for this kind of variable that is not needed at the time of like immediately after class creation, that may be needed later on, we can use the lazy as well there, right? And lateinit cannot be used with, if you see, primitive types, right? That is one more important thing. So that's all about this lazy versus lateinit. Let's move on to the next chapter. So next chapter is scope functions, right? scope functions, basically what are scope functions? They are a set of standard library functions, right? That lets you execute a block of code within the context of an object. Basically, they provide temporary scope on some object or variable maybe, right? Sometimes we need to initialize object, then we can use some of these. Sometimes we need to access some nullable values, then we can use some of these. We'll be understanding all of these one by one. Suppose first of all, let's understand about the let, right? I have one variable that is user, and let's say dashed, and we have one, and just suppose this variable is nullable, right? And now just suppose if I want to perform some operation here, right? If you see, we need to replace it with safe call, right? Either we can access it like this, but if this way, we need to access some other variables as well, right? We need to use it multiple times. So what we can do is, instead of doing this, we can use the let operator here. So what it will do is, let me add that one as well here. So if you see, here we don't need to use that multiple times. So here this block will be only executed if this is not null. So right here we can directly use whatever we want to, right? If we want to call some function and use this variable, we can use. So here it is provided as it, right? This one on which we are applying. This is the receiver, right? This is called receiver. So this is available, receiver is available as it inside this, right? So here it is user, it. If you see, its type is user. We can print it .age int .name, and we don't need to use this safe call operator multiple times, right? Right, this is mostly used for safe call and chaining operations, right? Suppose multiple operations we need to perform, right? Let, and next one will be run. So for example, suppose whenever we are using some object initializations or maybe some kind of processing, sometimes we need to perform a series of operations on object and then return the result. And one more thing, whatever will be the last statement, that will be returned. Suppose if I return it, so it will be return the user, right? So this one, right? But if you remove this, then nothing will be returned. If you see, its type is unit, but if I add that, its type will become user nullable, right? Right. Just suppose we have StringBuilder, right? StringBuilder dot. So suppose, just for examples, on the StringBuilder we want to call like append maybe, right? Or maybe we want to perform multiple operations, right? So we need to use it like at multiple places, right? Suppose, just assume here I have SB is equal to StringBuilder, right? And suppose SB dot append, right? If I need to append anything, right? Suppose here also again I need to call SB dot append world, right? And suppose SB dot toString, again I need to call it to convert it into the string, right? So if you see, we need to use it multiple times. Similarly, so for these things, what we can do is we can just use SB dot run, right? If we need to perform multiple things, right? So here we can just directly access append, and here on the, this is the receiver type, right? And inside the run, this receiver type is available as this. Here it is available as it inside the let, right? And for this, suppose if you wish, you can use this, otherwise you can omit as well, right? So it will be applied automatically. hello. Then we can use world. Similarly, we can use toString, right? That's pretty easy. If you see, when we need to perform multiple operations, right, then we can use run, right? Now let's move on to the third one, that is the with, right? So, and here also the last statement returns the value, right? Whatever it will return, that will be the returned value, right? If you see, it's the string, this toString, right? Then this with, suppose we need to call multiple methods on some object, right? Suppose in case of, this is mostly used in case of object manipulations, right? Complex object manipulations, right? Suppose with some object we need to like perform some kind of complex operation. Just for example, if I show you, just for example, suppose with user, right, want to use its properties like this, this, right? Or this is just simple example, but in some cases there might be some complex calculations involved, then we can use the with, right? Suppose just I want to return something, here also it is available as this, right? With user. So basically user is nullable, so let's create one more variable here, maybe that is not nullable, right? So suppose we have this user2. Suppose I want to perform some kind of complex calculations here, but here I'm just manipulating the fields, right? But in other cases you might need to perform some complex operations here, right? str3 maybe, right? So we can print str3. So suppose in some cases, whenever with some object we need to perform some complex operations, right, then we can use with. Here also this receiver type, this is the receiver type. Here it is not the receiver type actually. Receiver is like on which these are kind of extension functions, right? So we'll be understanding about these extension functions later on which we are calling the method, that is the receiver type here. This is the just, you can see, argument, right? You can say, yeah, it is also, we can also say receiver, this one, right? If you see this one as well, this is the block code, right? And with this you can see this is the receiver. You can say it receiver, but ideally it makes sense here more, right? So this is about the with, right? For some complex operations with some objects, we want to perform some complex operations, we can use the with, right? And suppose now we have apply, right? So suppose we want to configure an object, so right, suppose just I want to create the object, right? So what we can do is, let's say well user, in some cases we can use this, suppose we have normal constructor and then we can apply there, right? So if you see, this is the required, this have required values, right? But suppose if I have some class here that is just a simple class, right? User 5 maybe, it have variables declared like this, right? And here if you see, can make them nullable and set them null initially. So just suppose we have some, like in some cases we can directly create first object, then we can apply like whatever fields we want to update, like this is for mostly used for initializations, right? We can initialize things here like coding, and then we can have age, like anything we want to specify. So like for some object initializations, right, we can use it. So here it is well, let's make it where, right? So this, and this will be returning this receiver, right? This receiver is of user type, so it will be returning that object, right? If you see here, it's type of user 5, right? Similarly, we can have also as well, right? So for example, let's say we need to perform some additional actions, right? Sometimes we need to perform some additional actions like logging or validation, maybe, right, on an object. So also function we can then use for that purpose. It is also similar to the apply, but it provides the object as an argument, right? So basically inside this apply, receiver type is available as this. That's why I have not used this here, but if you wish you can use, but you can omit as well. But here in the also it will be available as it. It's similar to the let, right? So let's say we have some file, example.txt. Suppose there is some file that will be created, but along with the file, after I will be creating file, I want some kind of logging or anything, right? So then we can use the also. After performing this thing, I am saying like, yeah, along with this, please do this one as well, right? That is like file it, because it is available as it is being created, and then it dot create new file. It created object, but then it printed like this file is being created, and then it created new file as well. This is kind of basically logging. We can perform some validation as well, like file type should be like this for some cases if we want some restrictions, right? So for those purposes we can use the also, right? We can print user 5. Here we are already printing, so let's just try to run it. If you see, it just printed. So first of all we printed this one. If you see what we printed, age and name for the first object, right? It printed 1 and test, which we initialized here, right? Then it printed the third string str3. If you see this one for the width scope, and then we printed finally user 5, right? And also this one, because by the time this, whenever this method is being called, so this will be called and this will be printed, because this is the code, so it will be executed automatically. It will be creating new file as well, right? If you see, if you just remove this is just simple code. We are calling this, creating this object, maybe this calling function, and then it is creating, applying the also as well here, right? This is about the scope functions. Let's move on to the next chapter, object keyword, right? So what is object keyword basically? So basically object keyword is, it have multiple purposes in Kotlin, right? So for creating singleton classes we can use the object keyword, right? Singleton means like only one instance of that class or object exists, right? Similarly we can have more purposes, right? Suppose if we want to create some constants or like static class, right? Like some static variables where we have some static class and then static constants or something, then also we can use the object. And suppose inside this inside class we want some static properties, then also we can use the companion object. There are 2 or 3 usage of this, right? Singleton, factory, we can use it for factory pattern as well, right? Anonymous object can be created using the object keyword. I will show you all of these. Let's see first example. Suppose I have object my singleton, right? And we have just simple function, right? And here if you will see, we don't need to create any object. This is singleton, right? We don't need to create any object of this, right? If I just print my singleton dot name, it will directly print that. This is kind of static class thing, right? In Java, if you know about static classes, right? If you see, it printed that, right? And we can call it that function as well directly. If you see, right? And second usage can be, just for example, we have some class, and inside that class we don't want the complete class to be static, but we want only few fields, right? Suppose we have this class, right, and companion object. Few things I want to be the static, then we can use the companion object, right? And then this expression inside this will become the static thing. Again we can use that similar way, right? Though that class is not the static class, but still these things, name and print name, these are the static method and property, right? If you see, let's name it. So name is same, let's make it something else. Let's say my class 5 maybe, right? If you see, it will also be printing the singleton. This is the variable and this is the method call, right? Okay, so but I will show you one more thing. Suppose if I have something here, just for example, we have age maybe, right? I have it 5. You will not be able to use that. You will not be able to print that. Why? That is not the static method or property, right? For that you need to create the object. My class 5, and then you can use that, right? ob.age, right? So that is the another use case, right? And third use case can be the object expressions, right? Suppose I have one interface, actually interface. If you see, suppose we have this my interface and I want to provide the implementation for this, right? I will show you how we can provide the anonymous implementation, right? So if you see, we can use the object keyword, then this colon, and then here the interface on for which we want to provide implementation, right? Like this. Then inside the curly brackets we can implement the methods, right? Implement members. If you see, these two members were there, and we can provide this implementation without implementing this interface or without creating any class and object. We can directly pass it like this, right? And here if you like print anything, testing object, right? Anonymous implementation, right? And here just we can add anything, and here if you see anon dot abstract method, right? It will print testing object anonymous implementation, right? Now this, if you see, its type will be the anonymous object of my interface, right? So if you see, this is the object basically, right? And implementing this, but here if you will see anonymous object, it's saying the type is anonymous object, which is implementing the my interface, right? So that is the another use for this, right? So these are all about the uses. Let's move on to the next chapter, that is 29, delegation. So it is used to delegate properties and methods to another object, right? Suppose for some classes we don't want to implement that on our own, but we want to reuse it, but we want to reuse that implementation from somewhere else, right? Suppose we have one interface that is sound, and it have one method that is make sound. This is in reference to animal, right? Suppose I have one class dog. It is implementing this interface, and let's add the members. It have added the so dog make a sound of barking, right? And we have one more class that is cat, right? It is also implementing the sound. And suppose meow, right? It makes meow, right? And now let's come to one class. Suppose now I have one class that is pet shop, a shop that is holding the pets, right? And it have one property basically, that is sound, right? And so basically if you see, for example, it can either implement it like overriding the method, right? Maybe yeah, it's extending the sound as well, right? So either it can do it like this, but here then it need to type check, like if sound is like if for the dog it is for the dog or it is for the cat, that kind of thing, right? So that will be a little bit difficult to implement, right? But that thing what we can do is, we don't want to provide an implementation, but what we can do is this, it is implementing this sound, but how? If we provide our own implementation, we can use these brackets and then implement members, but we are using the delegation here. For that we use the by keyword, right? Sound by sound, this sound. So whatever we are getting inside this, it will be implementing that, right? So now I'll be showing you. Suppose I have one dog object, right? And right, and if you see on pet shop, suppose we have one dog, right? So then we can pass that dog here. That's pretty easy, right? And pet shop, suppose we have cat from that pet shop object, right? Then we can just directly pass the cat, and if you will be printing it, pet shop cat dot make sound, pet shop dog dot make sound. They will be using their respective methods, right? If you see meow, then bark, right? Actually we don't need to print, they are already printing, right? They are not returning anything. If you see cat, this is the meow, then we have this dog one, this is bark. So we didn't provided any implementation for this class, right? It implemented this interface, but by whatever is we are passing it here, right? So why this way, what we can do is, suppose we have some different kind of implementations, right? Depending upon some classes we are extending the interfaces. Suppose we have some different implementations, so that functionality we can directly use here without any other kind of, without using any other kind of logic here inside this, right? So that's the one use of this delegation. This is the interface delegation, right? Similarly we can have the property delegation as well, right? In that case we delegate the property initialization. So that is the example of the lazy. If you see, let me show you again as well. Suppose I have some class, let's say example lazy value, suppose string, I can use by lazy. So if you see this lazy, it is a kind of it is the inbuilt delegation implementation, right? So here we can print something computed and then return, right? So this is the property delegation. If you know this implementation of this property, we are not directly providing some value to it, but we are defining it lazily, right? So this is the so that this is called the delegation by this lazy. So this lazy block will be initializing. It's not initializing this value on its own. This block will be initializing. This is called the property delegation, right? So if you observe one thing here, that is the very important thing. So this pet shop, right? So this does not need to provide implementation of this making for the sound of the pets, right? It will be doing its own own things, right? That is the like single responsibility thing. It will be doing its own responsibility. But these, like suppose we have some kind of pet here, at the cat, dog, anything, those classes will be implementing those things, and it's just delegating its work to them, right? So that's all about this delegation. Let's move on to the next chapter, null safety, right? So what is null safety basically? Null safety is a very crucial feature, right, in the Kotlin programming language, right? It prevents null pointer exceptions basically. So if you see, variables in Kotlin are non-nullable by default. If you see any variable we have defined, if you see this cannot hold nullable. We have defined this like string. If we need to make it nullable, we can use this question mark, right? This is for you to make the variables nullable, right? Question mark symbol. Just suppose nullable string, right? String nullable, right? Here we have initialized it. But the now point is, because Kotlin prevents null pointer exceptions and it does not allow non-nullable values, but still if we need those values, we can use this operator. But then how we can ensure the null safety? Null safety means null pointer exceptions should not be there. We should use the null values carefully, right? So how it provides those kind of things, right? We can use, if you see, this is the safe call operator, right? What it will do basically, I will explaining it in a bit. Length of nullable string is length, right? I'll show you. It will be printing its length is 5, right? But suppose if this is null, then also nothing will happen. If you see, that's why it is called null safety. If you see, what will happen is it will print just null, but there is no null pointer exception happened here, right? Because we used this operator, but if we would have used this one, then it would have caused the null pointer exceptions, even if it will not allow you to do that even, right? Because it will ask you only safe or not null asserted calls are allowed on a nullable safe. That's the type safety the Kotlin provides. Here the Kotlin is forcing you, because you should not use this variable, right? That's how it's preventing the null pointer exceptions, right? But still, if we want to use it and without null safety, we can use this not null assertion operator, but this is not recommended. This is only we should use suppose if we are sure that this value cannot be null. Just suppose what can be the cases. Suppose I can show you. Suppose in some cases we have applied this check, right? Nullable is not equal to null. Here we know we are checking it is not. If it is not equal to null, then we are using. So here we can use the not null assertion operator, right? There is no issue with that, right? But ideally this should not be used. We should use this save one. And else what we can do is, suppose this is null, suppose we want some default value, we can use the elvis operator there, right? Default. Now it will print length of this is default, like suppose just 0 as a default, right? If I try to print it 0, we can provide default value, right? In some cases, if this value is nullable and we want to use some default, then we can use the elvis operator. This is called elvis operator, right? Similarly, we can use it for casting as well. String length equal to we have obj of any type, suppose that is the parent of every type, right? And then here suppose we need to typecast it. Here also we have to safe typecasting and non-safe, right? If we use this with question mark, right? So this is the safe casting, right? But if we use it without this, so and if this is not null, sorry, this is not string, and we just try to cast it forcefully to string, it will create problem here, throwing exceptions here, right? Suppose this is by chance it is coming as null, so it cannot be cast null to the string. So that's why for typecasting we should use the safe casting, right, using this add as question mark, right? So that's all about this null safety and not null assertion. Let's move on to the next chapter, any and nothing, right? So any and nothing are two interesting types in Kotlin basically, right? Any is used to represent any type of value, right? It can accept any type. Suppose we have some any type of variable, it can accept any type like string, int, anything, right? And nothing is also used to represent a value that does not exist. This is also the special kind of type, right? It is basically the subtype of all types, we can say it is. And this is the parent of every type. This is the child of every types, right? So let's say we have obj of any type, right? Suppose this obj is of type any and I have assigned one string to this, right? So now if suppose like I want to get some string from this, right? So I can do typecasting, right? Typecasting we covered in the some of the previous chapter, right? So this way we can do typecasting, right? Similarly, in the typecasting we have safe and unsafe typecasting. That is the typecasting concept, right? TR1, 2, and again if you see this one nullable, this one is nullable, so it is the safe typecast, right? In this, because this is typecasting it to nullable, so we need to make it nullable, right? Otherwise it will keep showing error. So any can take up like it can be it can take up any type of value. Suppose some variable is this, so to this variable we can assign anything. We can assign int as well if you see, right? Or we can assign double as well, right? You see there is no error, right? So that is the any type, that is the super type of every type, right, in the Kotlin. And then we have nothing, right? Suppose so nothing is basically it represents a value that does not exist, right? That's why we say it can be the child of all types, right? Suppose let's take an example. Suppose it can throw any error, right? And we have catch as well, legal argument exception. Stack trace maybe, or we can print message, any one of them, right? So here, or maybe what we can do is, let's say suppose I have one function that is the like fail, right? And I have added nothing to its return type, right? And let's say it throw illegal argument exception as well, right? It can accept suppose message here, right? So let's say just instead of this we use fail, right? So Then suppose for anything, suppose in some cases whenever function is expected to fail, so we can throw exceptions in those cases. So there we can use the nothing, right? Or it can be omitted as well, right? So if you see, but it is recommended to use in these cases. So we can use that in these cases, right? Sometimes something which is expected to fail at that places, we can use the nothing. We are saying like it's going to return nothing, no result, right? It will be like failing. So that's it. Why we can say it's not going to return any result, right? So if you see, if we add unit, it says we don't need unit, right? We can remove it if it says like this. But if we add nothing, it does not say that thing, right? That's how. So it depicts like, yeah, we can use nothing in those cases. So that's all about this any and nothing. So any is the, like, you can say parent of every type, right? And nothing is, you can say, like the child or subtype of all types, right? And it is mostly used to represent a value that does not exist. Like if a function never returns, maybe through exceptions, then we can use this, right? Let's move on to the next chapter. Generics. So what are generics, right? So it is very important topic. So generics are used to create type safe and reusable code. So generics are used to create type safe and reusable code, right? So generics allow you to define classes, interfaces, or functions with anything like with type parameters. Sometimes like we may need to reuse some code at multiple places, right? You mean like some classes, the logic we are writing that can be used with multiple types, right? So if we have that kind of thing, so then what we can do is we can like that can accept multiple types, that can work for multiple types. So that logic or code we can write at a single place, and then according to the type that can be used with multiple types, right? So that's where the generics comes in, right? So let's take an example of a class. Suppose I have a generic class, right? So how we can declare generic classes? The class name, class keyword, class name, and then these with these angular brackets we can specify the type parameter. This is the type parameter, right? It means it can work with any type, right? T. So suppose I have add method, but before that let's create list of items, and that is a mutable list of T type, right? It can be anything here, right? And then in the add it will be accepting the item of type T, and it will be adding that to the items, right? And similarly we can have delete as well, right? Remove, right? Similarly we can have get all items, right? And this will be accepting no parameter, but it will be returning a list of type T, right? So and it can just directly return the items dot to list, right? So this is the way how we can create mutable list. So in the coming chapters very soon we will be learning about the lists as well. You will be seeing like what is mutable list and what is list. So its type is mutable list if you see. But if it is returning the generic common list type, because mutable will be like they can be modified, but we want to return here from the read only list, right? So that is the list. That's why we are converting it to the into the list using the list, right? Now this repository is a generic repository, sorry, generic class, right? So it can be used with any type, right? I will show you how. Suppose we have data class, some product, and it can have like well ID, and let's say int, then it can have name, string price double, maybe. Yep. So let's say I will show you how we can create that now. Suppose let's first of all create the product. ID1 laptop and third one is the price, right? Similarly, we can create one more product, I think. Yeah, let's say product 2. And now suppose I want to like use that repository with product, this product class, some product, right? So what I will do is I'll be creating a product repo, right? So that is the product. Maybe let's rename it to product repo. So that will be a repository of type some product. So this class, if you see, this t is the type argument, and now sorry, that is the type parameter, that t which we are specifying here. This is the type parameter. This is called, right, type parameter. And what value it's getting, this is called the type argument, right? That is the difference between type parameter and type argument as well, right? So now this repository will work with this type, right? So I can show you repo.add. We can add product 1, then product 2 as well, right? And then let's say we want to print it product repo, right? Dot get all, right? Or maybe we can like do something here. Product repo dot get all dot for each println it, right? It will be printing each product, right? Let's try to run it. I will see if it's working or not. If you see, it printed 2 products because we have created them with the same ID. Let's add ID2 laptop 2 maybe, right? If you see, yeah. So now suppose this same repo we can use for other type as well. In this same repository we have created user class earlier, right? So this user class, right? So we can use it with that as well, right? If you see, what are the properties? Name, right? User 1, then age 21, right? Maybe user 2, maybe 11, and then user repo dot get all dot print, right? Now let's try to print it as well. If you say it's working for this one as well, right? So that's the power of the generics, right? We have just written the logic at this in this class for these common methods, right? And it's working with most of the types. This is kind in the like if you know about something about backend, right? So in the Spring Boot or so there you might see these kind of repositories, JPA repository, all those things. So they are the generic ones, right? So this is about the generic class. Now similarly we can create generic methods as well, right? Just for example, I will be just giving a simple example. We have just simple method, maybe get all items, and this should work with all types, right? So it will be accepting the repository of type T, right? And here T is. So if you see in the class, we are specifying it after the name. You need to remember this thing, these angular brackets. But in case of functions, it is used before the function name, right? And with space, right? So if you see here, what we can do is repo dot get all, right? And it will be returning a list of type, right? And this method can also work with both of them. I will show you. So just for example, get all items, and here I pass the product repo, right? And let's comment out this so that we'll be checking it if it's printing or not. Right. So you see it's printing, right? So it's working. So this method can accept any type of repo here and get all the records from that repo, right? This is the generic method, right? And similarly, we can specify uh, just for example, suppose here we are specifying one type, like T is the type and anything can become here, right? So, but in some cases, like we don't know about the type, it can be anything, right? We want to accept any type. So then we also use the projection for that. Here we don't need to specify the generic type, right? So this is the kind of like star projection is enough. We don't need to specify the generic type here. If you see, we have removed it from here and it should work. Yeah, if you see, it's still working. So this is called the star projection. These are the topics like which have very more detail. So they are in very depth. So we will not be covering them here because this is just the crash course. We will be later on like creating some other videos separate on these things, right? Similarly, we can specify some constraints as well, right? Let's say, suppose let's just make, just for explaining, suppose we have one functions, compare. Yeah, let's say just a simple function it is. And so here if you see, there is some type, this function will be working on some type, right? And if we want to specify like, yeah, this t have this constraint, right? So this should implement this comparable interface, right? If you see, whatever type we are using, that should extend this one, this interface, that should implement this interface, right? So these are the constraints we are specifying on the generic types, right? And that's all about the generics in Kotlin. Now let's move on to the next chapter. That is the lambdas and function types and functional interfaces. So we will be covering three topics here. Okay. So what are the function types? First of all, let me define the function type. So a function can be used as type. So basically, if you see it's a name like function type. Suppose integer type, integer is a type. Suppose function type, function is a type. Whenever function is used as a type, that is called function type. Right? Pretty easy, right? So in Kotlin, functions are first-class citizens. They can be assigned to variables, passed as arguments in functions, and returned from other functions. Like they can be treated like variables. That's why they are called first-class citizens, right? Just suppose I have one function that is square, and it's taking the int and returning the int, right? And it will be returning the square basically, right? So if you see this thing, so this whole thing is a lambda basically, right? So lambda, what are lambda? So lambda are instances of function types, and this is the function type. Suppose how we declare the variables, like using the variable, then its type, like this, like so, right? So this is the variable of type this, right? This type can be anything, integer, float, right? Similarly, here we have the function as type, because this is a function. If you see, this has one parameter of integer type. Here we only specify the type, or maybe we can specify its name as well if we wish, right? But we can specify type only as well, right? Then this is the return type. After this arrow we can specify the return type. Here we can specify the argument, then we can specify the return type, right? If you see, parameters are necessary, right? So this is basically a function, right? So if you see, this is a function type, we can say, right? And this whole is a lambda. This is used to create instances of function type, because this is the type and we are creating its instance as square and then providing the implementation. So this thing is called the lambda, and this is the function type, right? And similarly, we have one more thing. So first of all, let's cover the lambdas. Then I will be coming to the functional interfaces as well. What are functional interfaces? Suppose we have some tricks with the lambdas, right? Suppose we have one more lambda, and here, right? If you see, I'm specifying the argument here, right? Suppose if we have one argument, we can specify it here as well, right? Value like this, then the arrow, right? So then we can use this as value. So it is type alias to, so basically it is alias to type value now, right? We can use the value into value, right? Or maybe we can directly use it as well, right? It will be representing the instance of this, right? Whatever we will be receiving here, right? Square to it. Similarly, if we have specified the type here, we can specify type as well here, right? If we have not specified this function type there, then we can specify type here. So if you see, I have not specified any function type here, and here I have specified this, right? So inside this curly brackets, it will check like it have one parameter of type this, right? And here whatever I will be returning, that will become the return type, right? So if you see now, this will be a lambda of which is accepting the string and returning the string. So it automatically type inferred that thing, right? This is called the type inference. We have covered this in the previous chapters, right? So it is compiler is able to inference the type. That's called the type inference, right? Then we can avoid the return type here, and but we have specified it here. So it can automatically inference that, right? Similarly, we can specify some with receiver. We can specify lambdas on the receivers as well, right? Suppose int dot, if you see, these are like the extension functions. These are like the extension functions. So we'll be covering extension functions in the coming chapters, right? So this is the receiver type here, right? And this value is available as this inside this, right? Whatever is receiver type here, this is available as this here, right? So this plus one, right? So we can add one to the receiver, right? Using this lambda. This is just an example, right? Now let's come to the functional interfaces, right? So fun keyword is used to create functional interfaces. They are just like the simple interfaces. Then, so how we define the simple interfaces? Suppose interface, right? My functional interface, right? And then this, right? And it have like execute method as well. So if we just add the function fun keyword in before this, right? It will become the functional interface, right? And they are pretty easy. So functional interfaces basically, so how we can provide the implementation for them, it's pretty easy using the lambdas, right? One more thing, so basically they are called SAM interfaces as well, simple single abstract method, right? They have single abstract method. So whenever the interfaces have single abstract method and we have defined them using the fun keyword, they are called functional interfaces. So we can provide the lambda implementation for them, right? Fun interface IMPL. So if you see, I define it here, type because that have only single method. So we can implement them using the lambda as well, right? Here we need to specify there, because this have only one method, so we can specify that type here, functional interface, and then inside the curly brackets we can implement that one method, right? We don't need to specify override or any other thing, right? So suppose here this is the execute, right? So we can provide executing, right? And if I call it dot execute, so it will trigger this one, right? Let's try to run it. If you see executing, if I call on this functional interface, I call this method, so this is its implementation, right? We can define them using the lambda directly. We can omit this as well, right? Because it will be automatically entering the type, right? So this is all about the lambdas, function types, and functional interfaces. Let's move on to the next chapter. That is the higher order functions, right? So what are higher order functions? Higher order functions are functions that can like take other function as parameter. Suppose this is one function and it is accepting the another function as parameter. This will be called higher order function. Then also they can return functions as well. So they can return, suppose inside their return type also we can specify the function type, right? So in the Kotlin standard library we have some filtering and transformation method as well. So they are the all higher order functions. Like we will be learning about them in the coming chapters, right? So let's start with one example. So I have one function that is operate on numbers, right? And it is accepting the two parameters and which operation we need to perform on these two ints, right? That is the third parameter. So if you see this function taking three parameters, right? First two are the simple integer parameters, but third one is the a parameter which is of type function. That's why this is called the higher order function. So higher order functions can either take the other functions as parameters or they can return the function as well, right? So there, when the function type is inside the parameter list of the functions or inside the as the return type, right? So it can be occur in two places. Either it can be suppose occurring in the parameter list and or it can be occurring as the return type. So those functions are called the higher order functions, right? So here we can return whatever this operation will be performing, right? And its return type can be int. So if you see, I will be calling this and whatever operations I will be specifying here, that operation it will be performing on these two ints and returning that value, right? I will show you one example here, right? Result is, so operate on numbers. Suppose I have 10 and 20 and here I am specifying the operation. So one more thing, suppose we have some function as the parameter and that is the last one. We can omit these brackets. So basically we can specify them here as well. If you see here as well, right? We can provide it. So let's first of all provide it here. So here we can just like apply either the like sum or maybe abstraction, anything, right? So if you see, this is the third parameter, right? But if you see, it will, if you click on this, it will be saying lambda argument should be moved out of parentheses, right? Why? Because this is the last parameter. So then we can remove it from the brackets. We can just wrap up the function here and then just completely move it out of the function call. This is the function call and this one inside the curly brackets, right? This is the last argument. Whenever this is the last argument, only then we can do this, right? So it will sum them, right? If I print, you can see 30. So if you see, this is the implementation, right, of this operation. So if you see, it has operate on numbers have three arguments. Two are ints, we have specified them. Third one is the one method. So we will be providing its implementation from the place we are calling this. And then here it will be just calling that method, right? So we have provided its implementation using the lambda from here, and it just called that method here. That's why it returned that, right? So basically what happened is, whenever we called this method, so it then went inside this body. Inside this body, what it returned is, it called this function. It means it called this function, and this returned the sum of them, right? Similarly, it will be returning the product, right? Similarly, we can have one more thing. So we can have return type as well, like for header functions as a return type. Suppose get math operation, right? Just suppose we have one method. This method will be returning like which kind of operation we want to perform, and that is returning, it is returning as function, right? Its return type is function. So it will be returning a function which will be accepting two parameters and returning again the int return type. Basically we specify in the lambdas, we specify return type using the arrow, right? This is the general syntax of lambdas, right? We covered just in the previous chapter. These curly brackets, the parameters, then using this arrow, return type, right? So this kind of methods it will be returning. So now let's say operation name, we will be accepting the operation name here, and we will be applying the when clause here. Basically operation name, right? So whenever it is add, it will be returning a lambda function a comma b that will be returning the sum of those two numbers, right? Then we can have subtraction multiply as well, right? Finally we need to specify else block as well, and suppose here we don't want to do anything, we can just return something with like 0 or maybe, right? So this operation name, let's specify it as string, right? So if you see, whenever this operation can be anything like add, sub, multiplication, right? And what will be returning from here? So this is a simple math, basically a function, right? It will be accepting two parameters and returning the sum. Then it will be like subtraction minus, then it will be accepting two parameters and multiplying them, right? Else case is like some default scenario we need to specify in the when clause, right? So we will be implementing, sorry, we will be checking it as example as well, right? Suppose operation is get math operation. Suppose I got the add, right? And then you will be checking its type will be the function type, right? If you will see int two parameters, it is accepting and returning as int, right? And if I call this, we can call them like the normal functions, right? So it returned, what it returned is this function type. So now its type is, you can see it is a function basically which is accepting two parameters and returning the integer. Parameters are also of type integer. So we can specify 2 comma 3 two parameters and just call it like simple function, because this is a overall function basically, right? If you see 2 plus 3 5, it returned that, right? So we covered few things about higher order functions as well, right? So that's all about this. Let's move on to the next chapter, inline functions, right? So what are inline functions basically? So inline functions are inline, so basically they are inlined at the location they are called, right? So they are copied directly into their calling site. The Kotlin like compiler don't need to create function stacks like they, right? So they don't take up that space, right? So how we can do that? So it avoids like creating the stack frames and all other things, right? Function calls for, because it will be directly just copying the code of that function inside the place where we are calling that function. Suppose how we can create. So let's say I have one simple function that is like calculate operation and its return type is just init, right? We have just simple function that will be just calculating whatever we will be specifying inside its function, right? Let's say it will be calling this function directly here, just cal, and its return type is unit. So because we don't want to return anything, right? So whatever we will be adding here, it will be just performing that operation, right? So, and suppose this is just simple example, I make it inline, right? So if you see now, because this function is inline, so I will show you one example of this, how we can check it. Anything, any expression, simple, right? Suppose we just summed up two numbers, right? So whenever we are calling this function, basically, so this is inline function, so it will not be creating the like function call stacks here, right? There's no function call stacks will be created for this. It will just copy this code. So like this code, whatever is the implementation of this, that will copy just directly this code at the calling side. Here we are calling it, it will just copy the code. It will not create like the function call stacks there, right? Because for function calls as well, the stacks are created, right? Function call is added to the stack, removed from the stack, that kind of stuff like take a little bit time, but it improves performance removing those things, right? So ideally this is the extension functions and it works best with the extension functions, right? You can try to apply it on the simple function as well, right? So I have just a simple function and Kotlin compiler will show you one warning. Suppose I have add function that is adding inline, and suppose I have A and B and it's just returning A and B, return type is int. If you see, I applied it on the inline, I made this function inline, but this is not a higher order function, right? If you see what it's saying is compiler showing warning, expected performance impact from inlining is insignificant. Inlining works best for functions with parameters of function type. It means higher order functions. Here it is not showing that warning, right? Because whenever we are calling this function, this inline function, it will improve the performance. Just call this whatever is there. So this thing, it will just copy that. It will not use the function stacks for these calls, right? That's how it improves the performance of higher order functions, right? One more concept important which we have with the inline functions. Suppose I have one inline function that will be executing some block. It is like just a simple function, accepting the simple function. This is the block of function and just executing that, right? Suppose I will show you one thing. Println, suppose before block, and here we are calling that block. It means like this method which we are accepting as a parameter, we are calling it here, and we printed this after block, right? So sometimes what can happen is, I will show you. Suppose this block may return from here as well. So what will happen if this block, suppose this is the function and in that function we have used the return statement. So it will just return it from here. It will not come here. That will break the integrity of this parent functions, right? I will show you. Suppose let's just directly call this execute. So inside the execute, I have printed first of all like inside block, right? Then I return directly. I will show you what will be printed. if you see it printed like, so this execute whenever this is called. So this thing is the implementation of this block, right? This is the simple function which have return type in unit. It means it will not be returning anything, just a simple function, right? So because this is the single parameter and the last parameter you can assume because it is single, so then we can provide it directly without these brackets as we just learned in the chapter 33, right? So if you see, first of all, it printed before block because whenever we write this logic here, so what happened is it called this function, it went here, it printed before block, then it printed, then it like called this block. This block means all this code, right? So then it's printed inside block. If you see, first it printed before block, then inside block, it is coming inside block, and here it returned, right? If you see, it returned here, right? So this code block is skipped, it is not executed, so that should not be there. I think this breaks the integrity of this function. It has something to do here, but this thing made that wrong, right? So how we can improve that thing? We can use the cross inline keyword. If we use cross inline keyword, this internal like this function which is like as parameter, suppose we have this function and this function we are accepting it as parameter, this function cannot return then from this inline function, right? So you can see return is not allowed now here, right? If we have applied the cross inline keyword, right? So we can remove return, and that's the fix for this, right? Now it will not break the integrity, right? It will come here. Okay, so that's all about the inline functions. Let's move on to the next chapter, pairs and triplets, right? So pairs and triplets are some data classes. Actually, you can say them shortcuts. Suppose we have, if we have two values, just suppose function want to return two values, we can use pair for that. Similarly, for three values we have triplet, right? They are nothing but just data classes holding the two or three values. This is pair for holding the two values, data classes. Triple are the data classes holding the three values, right? So how we can create pairs? Well, pair, pair, right? Here the first value. Here we can define the another value. It can be of any types like string to string, integer to string, integer to integer, right? If you see, now it is of integer to string, right? If you see its type, pair of integer to string, right? So this way we can create it. And if we want to print the values, so it will print the first value, and using the second we can print the second value, right? Similarly, there is one more way we can create pairs. Pair 2, this is also the way we can create pairs, right? The 2, that is the infix function. We will learn about that in incoming chapters, right? As of now you can think of like it is just a function we can just apply with spaces function. So this function is called on this with this parameter, right? So similarly we can have triple as well, right? So let's say 1, then we have 1, then maybe let's take float value, right? Just for this example. And so it is similar. So for using the third value we can use the third keyword, third property, right? So first, if we call the pair dot first, this property will turn first property of pairs, this second. Similarly for triple we have first, second, third, right? If I see, I can see 1, then this 1, right? Okay, similarly we can print the pair 2 as well. Okay, if you see, this one is for the first one, this one is for the 2 to 2 second, this one is for the triple, right? That's all about this. Let's move on to the next chapter. So basic collections. So what are collections? So basically collections are like if we want to like create list of some data types, like list of some classes or list of any kind of data, right? We want to group them, right? You can see, so we want to collectively use them, so we want to collect, like, so in Kotlin we have three mainly used collections: list, set, and map, right? So let's cover them one by one. So for creating the list, we can use the list of function, right? And here we can specify the type. It's the generic, right? Generic function, right? So this will create the read-only list. This is not the mutable list. We cannot modify it. Now it will holding the only these three values, right? List dot add. So we cannot add the new element here. If you see, it's not even showing, right? So this is the read-only list, and how we can print it: for item in list okay. Similarly, how we can create the mutable lists, right? So if you see, that's pretty easy. Mutable list of function is used for that, right? But here now we can call the, suppose this is the m list. Here we can call the add method, if you see, and I want to add 4, I can add. So this is the mutable one, right? So similarly we can print this one as well. Okay, then we have sets, right? So what is the difference between list and set basically? So set will not allow duplicate values, right? List can allow. If you see I add one here, it will allow, right? But set will not allow, right? Let me print it actually, you will see. So if you see, first of all it's printing the first list 1 2 3 1, right? Then it's printing the second one 1 2 3 4, because 4 I added later on, right? And if you see, first list contains the, if I just print it like this, you will see, let's just not print it, just print it simply using this method, right? Then I'm list. Okay, let's remove it. If you see 1 2 3 1, it allows duplicates. Second one is for the mutable. First we created with 1 2 3, then we added 4, right? So if you see, similarly we can create set. This is the mutable set, right? And we cannot call the add method on sorry, this is not the mutable, this is immutable, like the read only, right? So we cannot update it, like we cannot add, right? So, and one more thing is, like if I just add one more here, the one same number, so what will you observe if I print it? If you see, oops, I created list instead of set of, this is the function. So now if you see, it just printed 1 2 3, not this, it did not included this one, it didn't included that, right? Because that already exists, so it does not allow duplicates, right? And you see, it's not allowing add as well. Similarly we can create mset, that is the mutable set of, right? So here I can add, right? For 6 it will work, right? Let's see. Yeah, it's working, it's separating. Similarly we have maps, right? So list, when we need list, when we can have duplicate items as well, we can use the list, right? When we know list will not be modified later on, we can use simple list, immutable. When we know this, we need to modify it later on, we can use the mutable list, right? Similarly we have set and mutable set, right? When we need unique elements and we don't want to modify, we can use simple set. But we want unique elements and we want to modify them as well, right? So we can use the mutable set, right? Now we have maps. Map of function is similarly we can use for creating the map. Map is basically a key value collection, so it requires two parameters, right? two generic type arguments, right? So basically it requires two generic type parameters. We need to specify two arguments, right? It is made of two type parameters, if you see, right? So we need to specify two arguments. So whatever we specify here, they are argument. Whatever is defined in the method, they are the type parameters, right? So if you see, it is basically a collection of pairs, right? I will show you. 1 to 1, right? 2 to 2, and similarly we can add pair as well here. If you see, 3 to 3, because it accepts the pairs. So you can see now pairs are useful here as well. They can be used as key value, right? And let's simply print it. You see, 1 is the key, 1 is the value. So numeric 1 is the key, alphabetic 2 is the value, then 3 key, 3 value, right? So similarly, if you see, if I try to do map dot put, you can see it's not allowing, right? But if we want to get modifiable map, so we can use the mutable map for that, right? You can see, and if you see now, it allows us put it at 4. Suppose we put 4, right? We can print it as well. If you see, it's modified here with 4. That's all about the collections. Let's move on to the next chapter. So collection transformations. This is about the collection transformation. So transformation means we are transforming the collection, right? Transforming means we are modifying them, we are changing them, and again creating the collections, right? There are few useful methods which we'll be learning about the collections here. Suppose we want to get the first element. Just even before, let's create a list of 1, 2, 3, 4, right? Okay. So from this list we can get the first first element as well, like using the get first. Not the get first, actually it was the first. Yeah, this one, right? But we'll print the first element. Similarly, we can get last as well, right? Right. Similarly, we have many other methods as well, right? And one more thing, suppose it does not have the first element, right? And we try to use it. So what will happen? If it is the empty list, we are calling the first, because it will not find the first element there. It will throw exceptions then, right? So what is the alternative then? First or null? We ideally use this one, because whenever we are not sure which one to use, we should use this one, right? Nullable first element, right? Similarly, we can use it for the last as well, right? Last or null, right? Okay, right. So let me just try to show you by printing. Similarly for last as well, so we can print last element, and let's try to run it. If you see, first element is first, last element is 4, right? It printed. Okay, and so this is about the first or null, this is last or null, right? These methods. Now we have some other methods. Suppose filtered list. We want to filter list, right? Suppose list dot filter. So let's say we just want even numbers, right? So if you see, this will loop over, this filter method will loop over this list and just filter out which will be satisfying this predicate, right? So it means the element of this list, right? Because it will be iterating it, so for its item can be accessed using the it. But if we want to alias it, we can alias it as well using the item like this, right? So if you see, and I print it filtered list, and if you see, it printed 2 and 4 because they are the even number, they are satisfying this. So it will be doing the filtering, right? It will be just getting some of them which will be satisfying this condition. So we can use the filter for that, right? Similarly, we can have the map method as well, right? Similar to the filter, right? Suppose we want to multiply each item by 2, right? So it will also loop over the list, and for each item it will multiply that by 2. So if you see, it will print 2, 4, 6, 8. So it multiplied each of them by 2. 1 into 2, 2, 2 into 2, 4, 3 into 2, 6, 4 into 2, 8. This is for transformation. This is for filtering, right? Now let's move on to some other methods. So all these are the kind of collection methods, useful methods, transformations we can say, right? Then we can have the group by as well, right? So let's say what we want to do is we want to just group by the items using the even and odds. So if you see, what it will print, if you see, so if you will see, so basically in the group by, what will happen is, so key, what will be the key? So basically what it will do is it will create a map, right? If you see it is creating a map of, if you see here, k, some key, and then list of t. So on the key it will add list. So it will be a map of integer. Suppose if it is integer comma, if you see here, if you see, yeah, you can see here, if you see map boolean and list of int. So boolean, why? Because this result is returning either true or false. That's why whatever transformation we have applied here, by that value it will create the key. So key will be either false or true. If you see false, true, and then in the false key it will group all the values which will be satisfying that condition. Like if it is false, right? So if this condition is false, it will group them into the false as key. If this condition is true, it will list all the items into this true, right? Key as true. So 2 and 4 it is true for even, right? For the 1 and 3 it is false, this condition. It did grouping by this condition. So basically key will be created by this, right? Suppose here we have true or false, 2 keys, right? So it will be create 2 keys, and for each key whichever value will be satisfying, it will be grouping those values, right? Then we can have distinct as well. So this is basically removing the duplicate elements. If we have some duplicate element as well, it will just remove that duplicate and it will just provide the unique elements, right? Then similar methods we have, very small methods like sorted. It will provide this sorted list, right? Sorted means by default it will be in the natural ordering, like 1 2 3 4, like the ascending order, increasing order, right? And if we want in the reverse order, we can use the reversed, right? Reverse list, it will reverse them in the descending order, if you see, right? And similarly, let's even just print them as well, right? Let's try to run it. If you see, it printed unique list because we already have unique. But suppose let me add one duplicate element. If you see, it's still printed 1 2 3 4. So one is duplicate, but it removed that, right? And similarly, if you see this sorted, it printed it in the increasing order 1 1 2 3 4. And so this reverse will be providing the reverse view, right? If you see from the reverse, it will start from the reverse, the reverse view of the list. It will start from here 1 4 3 2 1, right? And if we don't have the duplicates, it will be just kind of a descending. It will automatically become descending order, right? But ideally it will provide the list. It will start the list from the end and till the start. It will go till the start from the end, right? So that is the reverse view of the list, right? But and if suppose we want to sort in the descending order, what we can use is sort descending, right? It means in the decreasing order, right? If you see, it will be like 4 3 2 1, right? Okay, cool. These are some of the useful methods. Then we can have the associate. So we can use the associate method as well. List dot associate, right? So associate, it will create it star 2 maybe. So if you see, it will again create a map, right? But it will be a map of int to int. It will not creating the list, right? So basically in the associate, we will be like returning the pair because it will be like we need to associate this means the list item to something like this multiplied by 2. So it will be associated with 1 will be associated with 1 into 2 will be associated with 2 into 2 4, right? That kind of stuff. It will again be creating the map, but if you see, it will be a map of just same type of elements, right? Key and value will be the same type, right? We can apply some, like we can do some mapping. So for the each value we can do some kind of mapping, right? Suppose for the table or any kind of things we can use this. So if you see in the group by, it's just the key, and if you see, this is the simple type and then this is the list. So that is the difference. In the associate, that's not the case, right? So it will be just the same type of values, right? Then we have the associate by, right? Associate by. So associate by means, so key here, key will be the value of key selector transformation, right? So this will be the key basically here, like it. So key will be determined by this, something like we have in the group by, right? Associate by this key, right? But I will show you the difference, maybe forgetting the, let's print it. So if you see here, we have for the false we have 1 and 3, for the true we have 2 4. So all values, right, in the group by, the associate by and group by are mostly similar, but few differences are there in the associate by. So what will happen is, it will just get the last value which is satisfying this condition. Suppose first of all, it will be like how many keys can be there. If you see, either this condition will be true or this will be false. So 2 keys will be there according to this predicate, right? So it will create 2 keys, but for the values, suppose for the false we are getting 1 and 3 here, but it will pick up the last value here, right? It will not be creating that, like it will not be associating them with the list. So basically it will be just getting the last element. But in the group by, it will be just getting all the items which is satisfying those keys, right? So it will be getting all the, it will be basically grouping, right? But here it's not grouping, it's just getting the last element from that predicate satisfying list, right? And then we can have associate with, right? So what is this? So associate by means this becomes the key, but associate with means key will be the element, right? but value will be this transformation. Here the key is this transformation and value is the element. It becomes the opposite of this, right? Associate with, it means it's associating each element with something. With means it is associating key with the value, right? So we can remember it like key with value, right? So suppose it will be like something similar to this. If you see, right, it is associating this to this, but we have here that similar thing can be achieved with this one as well. If you see, this is the similar to this basically. Even we can print it. If you see, one associated to two, because each element it's associated, it's getting them associated to their 2 multiplier, right? Multiplied by 2. So 1 into 2 2. For 2 it's associating with 4, 2 into 2 4. For 3 it's 3 into 2 6. Similarly, if you see, this one is also the same, right? But here we have both key and values are under according to our logic, right? But here we are just key is the element and value is whatever we are getting from here, right? But here it was the like key was determined by this and value will be from the list, right? So these are the associate. Then we can have partition as well, right? So if we want to partition list in the 2 partitions, right? So we need to specify some predicate here. So conditions, it will create 2 partitioning of lists, right? One is the like which are satisfying this, another one is which are not satisfying this, right? So even if you printing this, so you will see it created 2 lists, right? One is 2 4, second one is 1 3, which are satisfying this. One is the that list, another one is which are not satisfying this. It created basically 2 partitions, right? And if you see what is the type of this, so pair, basically it is pair of lists, right? Pair of lists. If you see, we can print the different as well, different partitions, first partition, second partition, right? This is the partition method, right? Then we have very important method, that is just suppose join to string. From the list we want to create string, right? It's pretty important, pretty easy method and very important. Basically it have few properties as well. If you see separator, what kind of separator we want to use, suppose we are using this space, and what kind of prefix we want to use. Suppose in the prefix we want to just use this, and in this postfix suppose we want to use this, and space is the separator. So according to it will start the from start the string from this, separator will be this for each element, and then ending with this, right? So if you see, but this we don't need like the last one, transform. If we don't want to transform, we can directly use this one as well. But if we want to transform it with something like this, or maybe any kind of transformation we want to perform, right? So basically what will happen is here, so on this integer basically we need to convert it into the string. Then later on, suppose if we want to perform some kind of transformation here, then we need to make sure, because it should return this string, because this will create this string only then, right? If you see, it created this string, so this is the string basically, right? We can use anything here, right? If you see, we can use this one as well. If you see, this is the string with spacing, but this is the transformation. If we don't want to use transformation, so we can create it without them as well, right? str2, so first one will be, let's say, without transformation, right? So if you see, it printed 1 2 3 4, it printed with transformation 2 4 6 8, right? It's very important method, right? So that's all about this. Let's move on to the next chapter, operator functions, right? So what are operator functions, right? So basically operator functions allows us to define custom behavior for some operators like plus, minus. So what we can do is, suppose we have some data classes and all other classes, so we can apply the plus as well on them, just like we apply the plus on the integers, right? Suppose we have data class, can we apply plus on them directly? No, but we can use the operator functions for them, right? I will be showing you how we can do that, right? Just suppose we have some data class, right, point, and it have to like coordinate, if you say well y, right, is also of integer type. So here if you go and you, for defining the operator function, we need to use the operator keyword before the function, right? And then define the function name, right? So for operator function name, basically these are the predefined functions. So if you see this plus, this is the predefined basically, right? So this we can use the with operator only, like operator function. So if you see, so this plus will be like creating the custom plus, so we can then use the plus operator on this class, right? I will see you how we can do that. So that will be just returning the, so if I just want to add these kind of 2 points, so that should add like x to x and y to y, right? So x will be, it will be accepting something here as well, right? So that like it will be adding 5 plus 2, so on 5 it will add this like 2. I will show you how, right? So x, suppose x will be the x plus other dot x. Similarly we can have y as well, other dot y, and like this, right? So we just defined the function operator fun plus, so then whatever the class type is there, we can accept that argument and then we can return that as well, because what it will do, suppose we will be adding the plus on 5 plus 3, so it is working on the two integer types, right? One is this, which is the input, another one is this, suppose this is the parameter, it is calling the plus on them, so it will be returning the result of same type, right? Whatever the type of this parameter, right? Similarly we have point here, and point is the argument and point is the return type, right? So but now if you see, and now if you see, I have created here one point, that is x is 2, y and 3, and this is the point 2. Suppose y, x is 3 and y is 6, and now let's say I just want to get the point 3, which is the sum of these points. If you see, we can directly call the plus here, right? But if I just remove this, you will see it will not allow you, right? Unresolved reference plus, right? So that's the power of operator functions. They are very interesting feature of the Kotlin, right? So if you see, and if I even print, it should work as expected. Point 3 dot x, point 3 dot y. If you see 1 and 3 4, then 3 and 6 9, right? So similarly we can have another operator functions as well, like minus, right? Minus, right? So name should be these, some name are defined, so you can check in the documentation. Some name are predefined keywords. We cannot do minus like anything from our like minus define this, no, we can't do that. So we just need to define them using the same naming which is defined, right? That is the predefined keywords, right? So for minus, let's say we just do like this, right? Similarly we can have times as well for multiplication, right? So in the times, if you see, it will be just, so here let's say we can get the multiplier, right? So yeah, so here we will be just multiplying that value with this, or even we can use it, we can call it scalar, maybe scaling that. So phi, similarly y to scalar, right? If you see, I will call that, so suppose on point 3 star I call 4, so it will be allow that, right? For multiplication. But if I remove that, it will not allow, right? If you see, it will not allow, right? And now we can get our result, maybe 0.4. We can directly print that and see. If you see, x is 1636, it multiplied both x and y coordinates with 4, right? Similarly, we have many others predefined operator functions, plus, minus, times, div for division, remainder, right? Similarly, we have unary plus, unary minus, increment, decrement. So they are not limited to the integer and floats like primitive types in Kotlin. That's the power of operator functions in Kotlin, right? So let's move on to the next chapter. That is the infix functions, right? So what are infix functions? They're a pretty interesting thing, right? So if you see, I just created earlier a pair with using the 2, right? 1 2 4, or maybe 1 2 1, something like this. So this is a pair, if you see, right? But this method, so what is this basically? So this is the method basically, infix functions. If you see infix function, it is accepting 2 type parameters, and on the first parameter it is calling the 2 on with second parameter, right? On the first parameter it is calling 2 with the second parameter, right? So what it will do is, so just it allows us, if we use the infix keyword before the function, it allows us to call the functions using this without any kind of function calls, right? Directly with this space, right? And one very interesting thing is, like, it can allow, we can specify as many spaces as we want, right? So these are the infix functions, right? So we can define our custom infix functions as well. So if you see here, we define the point class. Let's say here we define some infix. So they are like similar the way we create operator functions using the operator keyword before function. Here we can use the infix keyword before function. So let's say on the point we want to call the move by, right? So like by how much offset we want to move that, right? So what we can do is, so it is basically extension function as well, if you see, right? So they are just kind of extension functions, right? But with infix keyword, right? So if you see this dot x plus offset dot, or maybe just offset, so because we are moving it, so or either like move by some value as well, we can define it, right? If you see this dot y plus offset, right? And it should return point, or maybe we can just get some point itself as well, right? Offset dot x, some different x, right? For if we want to get the same value, we can use the integer as well, but if we want to get them like different values, so we can just use the point as well. We want to move the point by some point offset, right? So if you see how I can call that, point 1, so I created 1 point, so that is the x13, right? And now you will see point 1 move by, I will call the move by, suppose I have one more point 2, that is the maybe 2 to 4, I can call that point 2 here, right? So point 1 will be moved by point 2 and we can get the point 3 there, right? So if you see now point 3, you will see it was the 1 3, right? So then we moved it by 2 4, so 1 will be x point will be moved by 2, so it will become 3, 1 plus 2. Then 3 was moved by 4, it become, maybe we missed something, yeah, we added x here, we need to use the y, right? And then if you see y become like from 3 to we moved it by 4, right? So that's how we can call the infix function. That's also pretty interesting. There are so many interesting things in Kotlin. If you see operator functions, extension functions, infix functions, right? So that's all about the infix functions. Let's move on to the next chapter, Typealias, right? So Typealias. So basically some people pronounce it as like Typealias, some people pronounce it as like Typealias. You can do whatever you find easy, right? So Typealias or Typealias, right? So it is a keyword basically used to define or used to create an alias for an existing alias, right? For an existing type, right? So this can make just code more readable and concise, right? So just let's say it has few use cases like simplifying the type names, complex generic types, function type. There are multiple places where we can use them, right? So let's say type alias user id equal to string. So basically the type, I am making just a user id type alias, so this will be just a string, but I just given it a different name, right? And if you see equal to 5, right? But if you see it will not take, because it will not take integer because its type is string, but it have type alias that to the type alias that to the string, right? So basically, but for the naming conventions we are just saying like this is the user id one type, just for the readability, right? So we can type alias them, right? Similarly we can have some maps as well, right? If you see type alias string map, for complex things it makes sense, I think, to do this, right? So string to string, that kind of map we can create, right? So if you see we can define its type like this and map of 1 to 1, right? So if you see we can take it as in place of map where type is map of string to string, just for the like readability. If you instead of just defining this type, we have type alias did to the string map, right, for readability, right? Similarly we can use it with lambdas as well, or function types. If you see, suppose I have one function type which is accepting the integer type as argument and returning the unit, nothing it means, right? Unit is like the void in Java, right? So I can just call it maybe click handler, right? So then let's say I can define one function. Suppose in the function, suppose I want to set the click handler, right? So I can just use that type here, right? Click handler, instead of just using this type, like it's just increasing the readability. So it's like increasing the readability by like, now we know like this is just a click handler, right? So instead of using this type, right? And if you see we can call that, because this is obviously a function type, right? Because this is obviously a function type, right? Click handler, right? So if you see, because we can define its type and then its value, because this is simple method like the lambdas we have used for implementing the function types, right? This is the function type alias, right? For this is the function type, we have used the type alias for that, right? So here if you see, this is just the implementation. So in the implementation, just suppose handling click event maybe, right, and doing something. So if you see now, I call this at handlers and I pass this click handler there, right? If you see now, it will print, because on the set click handler I called this, and what will happen then, it just called that function, right? So let's move on to the next chapter. Coroutines, suspend functions and dispatchers. So what are coroutines basically? So basically coroutines are like lightweight threads. So they are similar to threads, but they are lightweight, right, than threads. So basically we need coroutines to perform some work asynchronously, right? For asynchronous programming we can use the coroutines, right? So few differences like between threads and coroutines. So unlike threads, they are not tied to any specific thread in the underlying operating system, right? It means threads are tied to some specific threads in the underlying operating system. So that thread was controlling the threads things, right? But instead here they are managed by coroutine dispatcher. So which determines the thread or pool of threads they will execute on, right? So basically suppose if we are fetching some why do we need coroutines? Basically suppose if we are fetching some data from the network, right? So if we are fetching some network data, right, so we are calling the API there, right? So if in case of some UI related apps like projects like in the Android app development, so doing that thing directly on the UI thread is like that will make the UI thread blocked, right? So that will resulting in poor performance of the app will crash, memory will be like become too less, right? So these things will be happening with those. So for that purpose we need something that can execute that API call in asynchronous way. Asynchronous means non-blocking, that will not be blocking, right? So for that thing we use coroutines in Kotlin, right? So for asynchronous programming, right? So few things which we need to know about the Kotlin coroutines. So as we will be creating some examples, I will be explaining to you. So few things are like Kotlin context, dispatchers, right? These are the main important things which we need to know about, right? Suppose so each coroutine like will be returning a job which we can use, and basically that is the handle to handle the coroutine, that can be the handler, right? So just here suppose we are in the main method, right? So life cycle of this program will be till this bracket, right? Whenever we will be executing this, so it will be running till it reaches this bracket, before this bracket, right? So but suppose if we want some code to be like, if we how we can keep it alive, so for that we will be adding the delay in this, right? That delay will be only used for making it working with our example, right? Suppose we are fetching the network data from the network and we need to add some delay there, so how we can keep this thread main alive for that much time, right? So for that we will be adding one delay as well. I will explaining whenever I will be adding, right? So let's say, so here I will be using the run blocking, but so because we need something like where we can call the suspend functions or like coroutines calls, right? They cannot be directly called here. So just for example, let's say if I try to call the launch here, you will not be able to do that, right? Because that will not be available outside the coroutine scope, right? So launch is a coroutine builder basically, right? So we'll be learning about that soon. So this is just a, this is basically this is used in the unit testing, right? Most of the time this is the blocking, this will block. So this code will block this main. Whenever we will be executing this line, it will be blocked. Once this will be completed, then it will go here, right? So ideally we don't use this, but here we are using this for testing, right? Suppose I want to create some coroutine, right? So we can use the launch method for that, right? Simple launch method. This will create a coroutine, right, for us. And suppose, and I want to suppose here we are doing the API calling, right? For that we are adding the delay. So delay is just adds this much delay. This is the non-blocking function. So whenever I will be calling this, so whenever code will be reaching here, so it will be like this much delay will be added here. So after this much delay, it will be reaching to this line, right? Next line. Here it will be waiting for this much delay, then it will be going to next line, right? That is the delay. But it will not be blocking the main thread. That is the asynchronous, right? Non-blocking delay. So it suspends the, so basically it suspends the, so what will happen is basically program will not block here, so that will be just get suspended here and it will continue to the next part, just this. So basically what will happen is whenever this it will be encountered, so this coroutine will be just suspended for 1 second, but other things inside the main method will be executed, right? So suppose here in the run blocking, suppose here we have some other things, they will be keep executing, but this will be just suspended for this much time. After that, this much duration is completed, it will come back here and return, right? So that is the basically suspending of the code, you can say, right? And that is the non-blocking. It means it is not blocking the other things. So here we have some other code. That code will not be blocked basically, right? Even if we are using the delay here. So that's how we can say it is non-blocking delay, right? Suppose then here I am printing the something like API fetch, right? And I will show you. I will try to run it. First this line was printed, right? If you see, but ideally if we see code will be starting executing from this, so it will be printed, then this will be printed. But no, because here we have this delay. But if you see code first, after coming to this line and after coming to this line, code this thing got suspended and control flow returned to here, right? That's why it printed this. And then after this delay is completed, that then again this coroutine returned this thing, right? Control again come back to here, right? That's how the coroutines work. And this part is whenever we use some kind of delay or something is there, that is called the suspension. This suspends the code block, and that is the non-blocking. This will be suspended, but other code block will be executing, keep executing, right? So that's why it is called non-blocking delay, right? That is the suspended delay, you can say, right? So this launch is, what is launch? Launch is just a simple method, right? So this is used to create coroutines, right? And if I can specify dispatchers as well here. So what are dispatchers basically? So dispatchers can be of like multiple types here. If you see IO, right, main, right, then we can have the default, unconfined, right? There are 4 types. So they will decide like where we need to run this coroutine, right, on which thread, right? That kind of thing will be there. So what will happen is, so by default it will just take the context of this like its parent. So if we don't specify any dispatcher here, it will inherit the context from its parent basically, right? So run blocking, so where run blocking is running, it will be inheriting its context from the main, right? So by default it will be like that, right? So but suppose if we want to run this on dispatchers dot IO, right, for IO thread, right? Then we can specify our dispatchers here. So basically dispatchers specify the on which thread we want to execute our coroutine, right? For that we can use the dispatcher. And this whole thing, if you see, even if you see this dispatcher, right? So if you see in the it accepts the coroutine context. So basically these are the part of coroutine context, right? Dispatcher are the part of coroutine context, right? So if I don't specify this, if you see, so it will be using the dispatcher from its parent, that is run blocking, and here also we have not specified anything, so it will be using it from main, so that will be the main dispatcher, right, by default here. But if we have specified this one, so till here it was the main dispatcher, but here I change the dispatcher, so this part will be executing on IO thread and this part will be executing on main thread, right? This will be again on the main thread, right? So this is part of coroutine context. So what is coroutine context basically? Suppose if we are talking about something, sometimes we say like on which context we are talking about, like on which this talk is related to which context, on which context we are like referencing this thing, that kind of thing, right? That context is very common word. So that's the same thing here. On which context we are executing this coroutine, right? So context includes the job and dispatchers, right? Yeah, these things are involved in the context. So this coroutine, suppose even if you say this one as well, this will return a job basically, right? That is of type job, right? So, and if we want to cancel this coroutine, we can just call it cancel. So this will be cancelled then, right? I will show you now. If you see, it came here, right? Then it came till this delay. After it came to this delay, then it come here. So, right? But this printed this one, but this job is cancelled just after that, right? It didn't finish that because it got cancelled, right? After it came here, but here it got delayed, then it came here and then it came here, so it printed this and just suddenly it got cancelled, right? That's why it didn't execute this one. Before printing this one, during this delay, it got cancelled, right? So this way we can cancel the jobs as well, right? So similarly we have other coroutine builders coroutine builders as well, like launch, async, run blocking is also a coroutine builder if you see, but this is the blocking one, so we don't use this in the mostly in main code, like in the UI things or in the view model, right, or in the programming. So this is just used for the unit tests mostly, right? So let's talk about the dispatchers again. So 4 types of dispatchers are there basically, right? So dispatcher.default is, so if you see default, so dispatcher.default is for CPU intensive tasks such as complex calculations, image processing, where we need to perform some logic, we need to calculate something, right? That is complex, so there we use the CPU, right? And similarly this uses a shared pool of threads, right? So that is equal to the number of CPU cores. Suppose we have 16 CPU cores, so we will be having a shared pool of threads where we will be having 16 threads, right? So it can pick up any of them to run, right? Similarly, we can have the IO thread, input output, right? This is for like something like the network calls, file input output, and database operations, right? So input output, like getting something or printing something, that kind of stuff, right? It is also backed by a thread pool, so but that can be a larger number of threads. That is not limited to the number of CPU cores, right? It can be like more than that as well, more than those. Like suppose if we have 16 core, but then threads can be more than that in case of this dispatcher.io. So it's a shared pool is containing the more than the CPU core threads, right? Then we have the dispatcher.main. So that is just for the something like the task which we need to run on the UI thread. Suppose in the Android app development you need to perform some kind of things on the UI thread as well. So there we can use the dispatcher.main, right? Then we have the dispatcher.unconfined. So for the confined basically they are not confined to any specific thread, right? So they can start in the current thread, but they can resume in any other thread as well. So they will not be using the same thread. They are not confined. It means they are not confined to any single thread. That's why they are called unconfined, right? So that's all about the dispatcher and the launch, and we learned about dispatcher, coroutine context, and now few other things are also there which we should know about the coroutines, right? Yeah, one more important thing you can try that can be useful for you. So if we want to check out like in which thread I am executing, right? So thread dot current thread, right? If I try to print it here, you will understand. If you see, this is the main thread, right? But this one, this launch thread, this one is the default dispatcher, right? This is not the main thread, if you see, but this one is the main thread, right? If you see, this one is the default dispatcher worker, that is not the main, right? So that is on the some thread from the IO pool, right? That's how we can differentiate them as well, right? Similarly, we can use the async await as well, right? So suppose async, right? It's also similar to that launch, but if you see, it returns the default type, right? And launch, if we don't want to return something from this, like where we are using the launch, that we can use this job, right? But if we want to get some kind of data from the like API call or something, we can use the sync there as well, right? If we want to wait for that data, right? So if you see, we can call await here, right? So let's just return something from here, like just 5. It will return 5. Let's print it. If you see, it printed 5, right? So using the await, we can get the data, whatever is the return by this async, right? This is also similar to the launch, right? But launch is about the like fire and forget. But if we want to remember that, so we can use the async, and we want to get some data, so we can use the async there, right? So we can use the async for concurrent execution of API calls as well, right? Suppose we have this one job, and suppose this one is the another job, right? It is returning 6, and suppose, and now just suppose if I want to them, if I want them to be executed concurrently at the same time, right? So how we can do that, right? Suppose if we have some list, so basically we can await all for both of them, we can await, right? So they will be executing concurrently, right? If I trigger them, so they will be executed concurrently. And whenever we will be calling the await, it will be basically suspending the coroutine, right? It will not block. Here if we call await, it will not block. It will be just suspending the coroutine until it returns, right? Again, this is non-blocking. We need to remember this thing, right? And if I print the data, so basically it will be holding 2 values, if you see, right? So this way we can make concurrent execution of API calls as well, right? Using the multiple async await, right? So that is about the async and await, right? How we can use them. Similarly, we can have suspend functions as well, right? Suspend functions are similar to the, basically you can say coroutines. They are kind of, they can be called from the coroutines itself, right? Suppose we have something here, right? Just anything you can see. If you see, we cannot use delay without suspend if we want to use. So if we want to use the something coroutine related, we need to make that function suspend. And the suspend function can also be called from either suspend functions or coroutines. So that's all about this coroutine, suspend functions and dispatchers, right? let's move on to the next chapter. So that is about the flow, right? So as we learned about suspend function, so if we want to return something asynchronously, we can use the suspend function, right? But suspend function returns a single value asynchronously. What if we want to return multiple values asynchronously computed, which are, suppose there is something which will be computed asynchronously, but we want to return them multiple, right? How we can do that? So you can use the flow for that, right? Right. So basically there are three kind of flow builders. We have flow, flow of, as flow, right? I will show you their examples, right? Suppose we have this simple flow, and that is just like this. This is the flow builder, right? And suppose, because we can return multiple values, right? Suppose we will be returning the three values, and we can use the emit function for returning the values. If you see, it will be returning a, so if you see, its return type is flow of int, because we are returning the int here. And here if you see how I can check that, again let's say we can use the run blocking maybe, right, for testing, right? So what we can do is simple flow, this will be returning the flow. We can call the collect method, right, on the flow to collect them, right? And we can print whatever is collected. Let's try to run it. If you see 1 2 3, it collected all of them, right? But this is happening asynchronously, right? Suspend function return one value asynchronously, but flow can return multiple values asynchronously, right? They are computed asynchronously, right? Similarly, we can have some other ways as well of creating the flows, right? So that is the flow to, flow of. This can be like some fixed values, or if you see 4 5 6, and again this will be collected like similar to the other one. Yeah, if you see 4 5 6, right? And similarly we can have one more way, that is the using as flow. Suppose we have some list, right? List of just suppose 7 8 9, any kind of data, then we can use that as flow. It will convert this list into the flow and I'm eating them then, right? Similarly, you see 7 8 9 as well, it got printed. So mostly we use them like if we want to observe the database changes. Suppose database got updated in the background and we want to observe those changes, we can observe this flow, right? Flow, right, using the collect. So this is kind of observable as well. If we see fetching data from the network, and then we can handle the UI state, and accordingly whenever data is fetched, so we can update the values of flow and then update the UI by observing these changes, right? So for those purposes we can use the flow, right? So let's move on to the next chapter, that is annotations and interoperability with Java, right? So basically annotations, what are annotations? They are a way to attach metadata to code elements. Like metadata means data about data, right? For data about classes, if you see, right? So they can be used for various purposes like code generation, configuration, dependency injection. If you see, if you use the, you will be using the in the Android side, so using the Hilt and other dependency injection framework, so you will be seeing multiple many annotations will be there, right? So they are the kind of annotations, right? And some databases as well use some, and data classes, if you see, they use this serializable annotation as well. You might not be knowing about them, so but still if you know about them, so these are the annotations basically, right? So we use the @ keyword to use the annotations, right? So suppose this is a simple Kotlin class, right? So if this class, and we have this value as well inside this, and suppose I have suppose I want to Yeah, suppose here I want to test them as well in the Java class, right? So if you see, suppose here I am testing that class. Just for example, if I show you, suppose this is the class which we want to use in Java. So because as you know, Kotlin is interoperable with Java completely, right? So if you see, this is the class, right? So if I create this object here, right, and if you see, I cannot access this value directly. If you see, no, right? Either it's set value or either it's get value, setter and getters, right? But if I want to access it directly inside that class, how I can do that? So I can use the JVM field annotation, right? And then if you see, I can directly access that, right? That's the role of JVM field. So it will be like, it will show error in Java compiler whenever we will be accessing the field which is not having the JVM field annotation. So it exposes the Kotlin property as a field to Java, right? Without getter and setter, but otherwise it will be available via getter and setters, right? Similarly, we have one more annotation, that is JVM static. Suppose in the Kotlin we have static class object Kotlin utility. Here we have one function, right? So if we want to, like, what will happen is, if we want to directly, I will show you, dot, if you see that method access is not available here, right? This one, right? But if I make it the JVM static, then it will be available. If you see, it's available, right? But if I remove this annotation, it will not be available here, right? So basically, this will mark a method or property as static when accessed. So if, though we can use this as directly in Kotlin file, we can use it like, just like Kotlin utility dot print message directly, right? Just suppose I have this test method here, and if you see Kotlin utility dot print message, we can directly use it in Kotlin, right? But we cannot do this in Java if we don't use the JVM static annotations here. So if we use these annotations, then we can directly use it similar to Kotlin in Java as well, right? So these are the two annotations about the Java interoperability, right? So I wanted to explain you so that you will know how few things can be like make more interoperable with the Java. So they can be like more, how we can access them or using the more original way, right? Suppose without getter and setters, this we can directly access that in, like, we will be doing it in Java. The similar way we access these things in the Kotlin, we can access them in the Java as well, but we need some annotations for them, right? Similarly, we have maybe some, so you might have seen some deprecated annotation as well, right? And similarly, you will be like, if in the Android development you will be there, so you will be accessing the serializable annotations as well, right? So all those are the annotations basically, right? That's all about this. Let's move on to the next chapter, that is the reflection. So what is reflection? So reflection is a feature that allows you to inspect and manipulate Kotlin classes, functions, and many other properties at runtime. Runtime means whenever program is executing, right? But this should not be used as much as possible, right? It causes performance overhead, right? But still I want to explain you these things, how we can use the annotations, or sorry, reflection, right? Suppose I have one class, just a simple class, your class, we can give it a name, and it have name property, right? And some function as well we have, right? That is just printing the name. Maybe if I want to get the K class for that. That is the like it represents a class at runtime in Kotlin, K class. So how I can get that? Suppose your class dot class, sorry, this scope resolution operator is there, two times colon, right? Double colon you can say, like this, right? And if I want to access the class, how I can access that? That is the basically that is the Java class, right? Class is the in the Java class is represented using this class, right? And in the Kotlin is represented using this K class, and in the Kotlin we can get the Kotlin K class using this, and then if we want to get it the Java class, so we can on this we can call the Java, we can get the Java property, right? That will provide you class, right? So these classes you can need. Suppose if you will be doing Android development, you will be using the intent services, many things will be there. I'm just giving an overview. So you will be might be needing some at some places you needing specifically in running the moving from one activity to another activity, you will be needing the class of the activity, right? So using this operator. So that's why I'm explaining this, how you can use these classes, right? Similarly, we can get reference of function as well. If you see, if this is the class, from this we can get its reference of this function as well. We cannot directly call it, if you see, right? But we can call it using the call, right? But this is just an example, so we can access these, and even we can check like few some important properties like what is the name of the method, annotations, is abstract or not, is external or not. These are the some properties which we can access, right? We can get the parameters as well, right? Return type parameters, visibility, many things we can access, right? So that is used basically at runtime to inspect the Kotlin classes, functions, many other things. But ideally this is not needed, we should avoid this due to performance overhead, but I just wanted to cover this in this course so that you will be aware of what is the reflection, right? Let's move on to the next chapter, synchronization. So what is synchronization basically, right? So for synchronization we can use the Mutex in Kotlin. So it is similar to the synchronized block in the Java, right? So suppose it is used to ensure that only one coroutine is accessing the particular shared resource, right, at a time, so that there is no race conditions happening, right? So let's say I will show you one example basically how we can create Mutex. So we can create it like this. So after creating it, suppose, and again if you see here I'm using the run block, but ideally we don't use it, that we have already covered in the chapter Coroutines. So this is the blocking one, we use it for testing purposes mostly, but in real world we will be using Coroutine scope, lifecycle scope, or vmodel scope, right? So this is the Android specific lifecycle scope, these are Android specific, this is the common one, right? So, and suppose I want to launch one coroutine basically here, right? And suppose there is something like this is like something shared code block maybe, or anything else, some variable can be there like which will be the like shared one, right? So, and suppose this is the coroutine, so multiple coroutines can access this code block basically, right? This one, right? Or you can say it is using some variable which is the common one between two coroutines. Two coroutines are updating the same variable of the class, right? That thing can be happen. So, and that can create some inconsistencies of the data, right? Because at the same time two coroutines are accessing some data. So how we can avoid that inconsistency, right? So we can use the Mutex. So how we can use Mutex dot with lock, right? So here we will be doing whatever is the shared variable or shared code block, right? Okay, so this is the way how we can use it. So what it will do is it will automatically perform everything, like it will release the lock once it is this code block is done, so it will automatically release the lock. It will acquire lock and then it will perform this code block, right? It will execute this code block, then automatically after performing this it will release this lock, right, on this code block, right? So similarly, suppose if some variable in the class might exist, so we can use this same way of mutex for providing the synchronization with the class variables as well, right? So let me give you one example. Suppose we have one bank account, right? Suppose I have one initial balance 1000, right? And suppose we have two methods in the bank account, right? One is the deposit, another one is the withdraw, right? So just suppose from one place I'm doing the deposit, right? So initially it is 1000. So from the deposit I did just 100 deposit and it should become 1100, right? But at the same time, while I was doing this deposit from other place, I did a withdrawal of 200, right? So basically what happened? So while I started this withdrawal deposit was also in the progress at that time, right? So this was in the progress, right? So because there is no check there to like only one coroutine can access, multiple coroutines can access that variable, right? So what happened is like at the time this deposit started, right? So user added this deposit, but this transaction was not updated, right? Suppose by the time this withdrawal happened, this transaction was not updated. So ideally this withdrawal should have happened on the 1100 and balance should have been 900 if it is everything was like proper, like synchronization was there. But what happened is like balance was, it took, so at the time it started its transaction, at that time this was not completed yet, it was already in the progress. So it took the balance, initially 100 balance as 1000, right? So it performed that 200 on this 100, sorry 200. So it performed this withdrawal of 200 on this 1000, right? So whatever left is 800, right? But ideally what would have happened? So it should have performed on this 1100 and answer should have been 900, because by the time it started withdrawal, this deposit was not completed yet, it was in progress. So that's why the initial balance it took was 1000, not the 1100, right? So what happened is at that time, so it finished, suppose anyhow it finished earlier, right? So it made the balance 800, but thereafter some time it updated balance to 1100 as well here, right? Because it completed just after this, right? So balance has become 1100, but what it should have been, right? What it should have been, so 1100 minus 200, so it would have been the 900 here, right? But this withdrawal is not actually reflected in the database due to the synchronization was not there, right? So to handle these kind of situations, so we can use the mutex there, right? Suppose let's say we have one class balance, it's holding the balance, let's say, and let's say it is of type int, right? Okay, and now let's say I have one suspend function deposit, right? And inside the deposit, so I will be using the mutex, right? So again mutex dot with lock, and inside this we can do our deposit. So how much amount we want to deposit, we can take it as parameter. So deposit will become right balance to the balance, it added that to the balance, right? Similarly we can use the withdrawal as well, right? right? So here also it deducted that balance, right? So now what will happen is, if we again take that scenario, so initially I was performing the deposit, right? So at the time I am performing the deposit, so what happened is like this mutex with lock on this balance variable, so it's accessing this balance variable. On this variable it took a lock here, right? And at the same time I started the withdrawal, if you remember, right? In the example I was giving you just few moments ago, right? So what will happen is, whenever we are calling the withdrawal, at that time withdrawal will not start, it will not come here until this block is completed. So basically that withdrawal will get suspended, right? When this will be completed, then this will be releasing the lock, and then this withdrawal will be happening, right? So that's how we can prevent the race conditions in programming, right? Concurrent programming. That is the synchronization, similar to the synchronized keyword in Java. So let's move on to the next chapter. File input output. So how we can read the reading and writing of files, right? So for that, basically just let's create some file here. We need to import this file and sample5.txt. Also it dot, let's say if it dot exists, we can say if it does not exist, we can check it here, then we can create new file as well, right? And write some data as well, right? Test. So this way we can create file, and how we can read it, it's pretty easy. So directly using the file dot, there are two methods, read text, read lines. We can use any of them, right? So let's use the read lines, then dot, let's use for loop because it will returning the list of strings. Then we can print each line, right? If you see, test, it printed this line, right? Similarly, this is the unbuffered reading. It will be reading content line by line. So we can do the buffered reading as well. For that we can use the buffered reader, right? So I will just show you how we can create the buffered readers. Inside this we need to use the file reader, and then we need to pass the class handle. Or if file handle already exists, we can directly do it using the file dot this extension as well, right? And then let's say take one variable of type string. So then we can use it using the use method, right? So if we use the use method, we don't need to manually close it like this. This thing we don't need to do, it will automatically do that for us, right? And here we can read it. So line equal to, let's say buffer reader dot read line, right? Not equal to null. So let's make it where let's say assign the line using also, right? And until this line is not null, you can say, it will keep reading this, and then we can print the line, right? So this one we are reading here, right? If we comment it here, then it's reading it from the buffered reader as well, right? Similarly, we can use the buffered writer as well for writing. Then there we will be using the, so there are two ways again. So either we will be using the buffered writer, and inside that we will be passing the file writer and the file instance this way, right? Or another way can be directly calling the file dot buffered writer this way, and then we can just write something there, right? So that's about this so file read input output in Kotlin. So this buffered reading is like a little bit faster because it reads data in the larger chunks, right? But this reads the data line by line. So for every line it calls the separate system call, right? But buffered reader is fast because it reads multiple lines at a time. You can say in the larger chunks it keeps the data in the memory, right? Some kind of buffer, right? So that's all about this. Let's move on to the last chapter, sequence. So what are sequences? So sequences are just similar kind of things, like we can handle the collections using sequences as well, right? They're similar to the lists, but few differences are there. So they are more efficient and lazy way compared to traditional collections, right? So why we can say lazy? So because it processes elements one at a time, not for the whole list. Suppose we are applying some transformation, it will not apply that transformation on the whole list, all the elements. It will just apply that on the element by element, right? But lists apply that on the whole elements, like so for that lists create some intermediate lists as well. So that's like some time taking. But for the small data, lists are fine, then we don't need to use the collections, right? Sequence, sorry. So how we can create these sequences? So it's pretty easy. So let's say numbers, and I will be creating using the sequence of, this is the builder, right? And then we can get it using the to list, right? If you see, it's printing 1 2 3, right? And we can have some other methods as well. So let's say from list as well we can get similar to the flow. We have as sequence extension function on list as well, right? So let's give it, you see it's printing again, right? So these are some two simple ways. And now let's say suppose I am just performing some kind of transformations on the suppose I want to filter like numbers, right? Suppose let's say I am filtering them like odd or even, right? Even I am picking up the even one, right? Dot map, then I am doing the mapping as well, and in the mapping let's say I am just multiplying it by itself, right? So in case of lists, what will happen is, first of all, on this list, so this filter will be applied on the whole list, like whatever is even, it will be filtering out all the elements in one go. Then in the second go it will be doing this, right? First it will be applying filter on the all elements, then map on the all elements. But in case of sequences, what will happen is it will be picking up the one element and then applying the filter and map on that one element, then picking up the next element, then performing these operations on that. That's how it's a little bit faster for the larger data, right? Because it will not need to create intermediate collections, right? And it is lazily evaluated. It will not evaluate anything until we don't use the terminal operator on this, like using to list, right? So that's all about these sequences as well. So this is the last chapter of this crash course, and so that's all about this crash course, guys, and I hope you have enjoyed it. And one more thing, so believe me, if you have watched it from the beginning till the end, I can say you will be definitely ready to dive into the Android or backend development, right? So that's all about this video. I hope you have enjoyed it, and if you have enjoyed it, please like, share and comment on it. Please subscribe my channel for more such content on this, and if you will be liking and subscribing, that will motivate me to create more videos like these. And I will see you in another video with another cool content. Till then, bye bye, take care, have a great time, keep coding.